universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Okay, I'm going to go ahead and then I'll bring you in shortly. Here we go.
All right.
Hey, folks, how are you? It is I, Mark D'Antonio, and I am here with our friends Calibos and Tiffany. So let us say hello to them. Calibos, say hi.
Hello, everyone. How's it going?
Yeah. Your mics might have been live before, but it doesn't matter. So we're cool. We're cool. All right. Yeah, so tonight, the sky awaits us. Yes, Ray. You don't like my talk? You can go to another stream. So anyway, yeah, and so I'm going to spend some time here. Our stream is all set up, ready to go. So I have the chat up now, which is great. Nice to see you guys. Donald Kunzer asked about Triangulum and NGC 604, which of course is the largest H alpha region in the Triangulum galaxy. It's way heavy over into the northwest, and I think it's not going to be visible to us right now. So sorry about that. But I want to say hello to everybody that's here. Papa Tom, how you doing, Papa Tom? How are things going for you? Donald Kunzray said hi to you. Kevin Williams, hello. I don't remember seeing you here, but you must have been here. Maybe you're here by a different name, typically. Cosmic Ray, what's up, Ray? And Daisy and Zoe Amethyst. Hi, guys. How are you? It's been a while since I've been able to hear that Lane is with you. Come on, what's going on? And it's nice to see you guys. And we have Stan from Two Rivers Observatory. Started his marathon, then the clouds rolled in. You know, the Messier marathons do require a clear sky. There's no doubt about it. But man, I'm sorry, Stan. That was a good try. After all that, where are you located, Stan? I think you told me once, but let's tell everybody. Okay, and then we have Alicia Vieras is with us. Hi, Alicia. Congratulations to Darlene. Winning was at 5th place nationally in cheer.
Wow.
I think.
Nice.
I think that's what it was. But you'll let us know. Old School's with us. Who's
Old School?
Who's this Calabos dude? Yeah, it's him right there. You can see him right there. Yeah.
No.
Doing his thing. Yeah, he and Tiffany are here with us tonight. I thought it'd be nice to bring them up again because people like seeing him. You know, he's very important to SkyTour live stream along with Tiffany these days. They actually are, and that's right. That's Tiffany over there. There she is.
More important.
Yeah. Oh,
The science.
Alicia, I'm sorry. I apologize. 2nd in the nation. All right.
Oh, wow.
That's fantastic.
Wow.
That is really fantastic. So,
right on. In the nation.
yeah.
Wow.
So congratulations,
That's incredible.
Darlene, if you can hear me.
Absolutely.
So that's cool. I'm going to guess that Alicia's the one hitting those hearts right now.
Oh, that was me.
Oh, that was
me
you?
too.
Okay, all right.
I'm hitting the hearts like crazy.
All right.
Oh, yeah.
All right. So anyway, this object that we're looking at right here, okay, this is a cool object, although you may not know it yet because I moved the bright star just out of view. See, there's some fuzzies here. This is a really interesting star system. Cosmic Ray, thanks, Mark. You're so welcoming. Well, you know, when you say something snide like you did, Ray, that you're going to get it right back. You know? Uh-oh, there goes a Michael Tarr Starlink right there.
Uh-oh.
Oh.
Calabos.
Yeah.
You guys, Calabos works at SpaceX, just so you know. Okay. So it's nice to have him here with us. Tiffany, it's better to have her here with us, but we got to take him too. Go figure. Oh, I'm sorry. Did I say that out loud, Mike? Mike is really generous along with Tiffany. They actually are responsible for our equipment that we give away. They donate this equipment to us. So those two people right there are real, is what I'll call superstars, that are superstar volunteers for us. You know, we have a number of superstar volunteers. You know, Izabela is a superstar volunteer to us. We have Tara and Marianne, who are part of the organization. They're superstar volunteers for us. We had Robin Curtis a while back, and she was doing a lot with our data and putting it into a database. Izabela is doing some of that now, too. Daryl, of course, is may or may not be here tonight. He's got to do some things tonight, but he may show up. And if he does come, we will welcome him, of course, with open arms, as we always do.
That's right.
All right. So now what I'll do is I will actually take a picture so you can see what it is we're looking at here. And right now, we're actually doing pretty good. I'm going to actually just move the telescope down just a little bit more. All right. And you'll see the stars just dribble upwards a little bit as I do that. Okay. Right behind here, you can see the telescope behind me. I wish I was in the observatory. Actually, I'm going to be in this building this coming Tuesday. So, because I'm heading out there to install the new all-sky camera.
That's right. That's right.
And that will be a really, really exciting thing to see. All right. So, I'm going to bring us... I just realized I went a little too far up. I'm going to drop us back down. Right to about here. Okay, right there. I want just a little peek of this bright star right here. But the object we want to see is right here. This is a classic location in the constellation Orion. And what it is a location where a dark nebula sits, a very famous dark nebula. Some of you have already figured it out. And this is a location where, as we live stack, you'll see, it's a location where the dark nebula is a place where there's condensing material. This entire region is a giant molecular cloud, not just the object that you're about to see, but everything around it. And of course, because the hydrogen gas is mixed in, all right, that hydrogen gas being mixed in, as you'll see right there it is, that hydrogen gas being mixed in is ionized by the hot stars. In this particular case, this star here, Sigma Orionis, is ionizing all of this hydrogen gas. Okay, and remember, this is in 3D, so it could be coming around and going behind, and it's really interesting. All this darkness here, this is all dark nebula, and from within the dark nebula, some of the stars are scattering, some of the stars' blue light is being scattered by the dust inside of here, and that's why it looks blue. For the same reason that the sky is blue. Same type of thing. It's Rayleigh scattering. It's a really interesting scattering process. All right, now, I believe we're good here. And so, yeah. So now what we've done is we've got two images that have been stacked, and we got one that was rejected. Let's find out what our full width half maximum is. Okay. All right, we're running it right about the limit. Yeah, so let's see if we get a next one to come in, or if it's going to get rejected as well. This number, if I keep this number, depending on where we're pointing, if I keep this number at a certain position, then we'll get round stars. If they drag out a little bit, this number is much bigger. Now, I don't have to use it. I can turn it off. And in the past, we have. But now that this feature is in here, this full width half maximum feature allows us to capture stars, and no matter how windy it is out there, we'll always get perfect images. Now that's really kind of cool. That's a really cool thing. All right, so let's go back to this is called a histogram, and let's stretch it out a little bit so we have a little more control. Then we'll slide this in here. Okay, you'll see our red, green, and blue curves. These are the data curves for the light coming in from the camera. And the white curve is the average curve. And that average curve is a curve which tells us where the black level is. Okay, if we climb this peak here, you'll notice that it gets darker, but we don't lose any data. Okay, we don't lose any data. All right, and if I cross that peak, then we start losing data. See that? So we don't want to do that. So we stay just to the left of the peak. Now I'm going to enhance this immediately. You're going to notice an immediate change. I'm going to remove the erroneous color. Darn it, Michael. You're in trouble for all these. All right, for this, now here you see there's a color noise reduction, and I got it pretty high up there. So when I click this, you're going to see an immediate improvement in the image. Here we go. Boom, look at that. So that's an immediate improvement because we removed a lot of the noise dynamically from the image. Okay?
Oh, yeah.
We can't remove Michael's noise, which is this guy right here.
Yeah.
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 You're gonna be known as the satellite guy, because
Oh,
you're
yeah.
the reason why we have that in there. Matter of fact, I believe you do work on the Starlink program, do you not?
I do work in the Starlink program.
Oh.
I do work for them.
Okay.
Yeah.
Well, you know what?
For now.
Right. From now on, every time we stream, I'll tell you. And what you're going to do is you're going to go down to satellite ops, and you're going to say, I want the Starlinks to have their trajectories changed.
Yeah.
All right.
That will totally
I
happen
know.
because I can make that.
Yeah, because you are just so important.
Yeah.
Yeah.
Not cool.
Yeah.
Oh, one day.
Nah, you know what, though? It's cool. I think that your contributions are actually quite well known there, or else they wouldn't still have you there. You know, and you've been through a lot medically. You've had some medical things. You know, I've had some
Oh,
crazy
yeah.
medical things myself. You know.
Yeah. Oh,
Yeah.
And Donald, no, there is no way to make them non-reflective. Unfortunately, metal will always, reflect some sort of light.
Well, they did. They did try to reduce the brightness of the Starlink satellites, but they still have. They still have solar panels.
Yeah,
And
which is
you can't do much with solar panels.
right.
You know? And and Donald, it's less the brightness of the small parts, and it's more the overall brightness. You know, because just like with stars, the bigger the star, the brighter they will appear to us. Okay, no matter how far away they are. If they're really far away, they'll appear very, very bright. Okay, Alnitak is a big star. That's this guy right here. It's the leftmost star in the belt of Orion, and that star at 1,500 light years away is a big O-type star. Right, big, hot, and blue, and that star, because it's so big in diameter, it's not a supergiant, but it's a big star. That star is a luminous and more luminous because it has a larger diameter. Smaller diameter, even hotter star might not even show as bright. Okay, so it has to do with a lot of that, you know. And so there's a lot of brightness that matters here. So we're gonna let this come in a little bit more, you know, and we'll enjoy this. The Horsehead Nebula, we can see some really nice details. We can start to zoom in on that too. Let's do that. Oh yeah, that's actually got some really interesting detail in it. You can see a little tiny star right there. Little tiny stars right there. There's one right there. And if we kind of move this down, you'll notice there's this pillar of material right here, which is really cool. And it's silhouetted by the brightness of this star. And this is all dust in here. When I say dust, what do I mean by dust? An absolute set of dust particles in this region that come from countless red supergiant stars that create molecules and carbon dust in their outer atmospheres, silicon dust, from fusion that they've acquired when they were formed. Okay, and then in their cores, when they go supernova, they blast all that stuff out to the interstellar medium, where it becomes a cloud of both gas and dust, like we see here. And this dust, it is, isn't it? And this dust is actually the stuff from which planets are made, along with the hydrogen gas in there. The hydrogen makes the stars primarily, and the dust will make the planets. Really, really exciting.
Wow.
Old School says, must be true, is getting crowded up there. Yeah, there's a danger.
Yeah.
And there's a danger that if we put too many satellites in orbit and there's too much junk up there, we could actually trap ourselves here on the planet because there'll be too much stuff up there. We won't be able to get up there. So NASA's got a project, which I think Michael might know about.
No, I can neither confirm nor deny. No.
Yeah?
I'll have to tell you guys, I did have a talk with my boss this week. I just returned to work this week, my first full week back at SpaceX, and I turned him on to this channel because I want him to know that what we're doing.
Excellent.
He's an amazing guy. His name's Micah, and he's an amazing supervisor.
Nice.
Very knowledgeable. Very he's just a great supervisor.
Excellent.
And he I told him that we do this stuff, so he may be watching, so I can neither confirm or deny. There's the only things that I am allowed to speak about are the stuff that has already been in the press.
Public, yeah.
And, but at the same time, I'm not too sure how opinionated I can be about those certain projects.
Oh, no. Well, you didn't know what I was going to say, so I can understand. You were afraid because it might have been jumping the gun on you. But the truth is, I was actually saying that NASA has on the docket some cleanup missions that are meant to go clean up space junk.
Oh,
Yeah,
okay.
and that's something that they're designing ways to do right now, because it's very important to clean up the space junk, because we don't want to be trapped here on the planet, you know.
Yeah.
And we could be. We
Yeah.
could end up trapping ourselves here. I want to say hello to Curtis Horn, who's here. That's Curtis, my buddy Curtis. Hi, Curtis. How you doing, man? Great to see you. Cosmic Ray makes a really good point. Without Starlink, we wouldn't be seeing this. Actually,
Right.
we would, Ray, but it'd be a lot slower because we'd be using HughesNet or Viasat. And however, I have to say, HughesNet is saying that they're going to have Starlink speeds, so I'm not sure if they've got an arrangement with Starlink, and I won't ask Mike that at all. But because I don't know if that's true. That's just my speculation.
Yeah.
Yeah. So I'll be, like I said to those just getting here, I'll be there Tuesday in the afternoon, and I'm going to be heading out to the observatory. I'll be in there with this beastie, and
Oh, you'll only be like one state over from us.
I know.
That's
I know.
cool.
Well, if you get in the car and start driving, you might meet me. No, I'm just kidding.
Yeah, we could actually.
That's a long ride.
It would take us like not
6
for us,
hours.
to Arizona. If that's not.
Yeah.
We do that driving from here to Contact and
All
back.
right.
Right. About 2.5 hours to Contact and back.
Well, but then to go to Mesa, where I stay, that's going to be another hour and a half. But,
Oh, okay.
And that'll break the bank right there.
So
It would have to be a weekend. It would have to be a weekend.
Papa Tom says, could we be cooling the planet by having so much space junk? Not that, Tom. The thing that actually cools the planet, to be honest with you, are all the jet contrails. We have so many more contrails in the sky that, of course, the people that are conspiracy guys think that they're chemtrails, but
The chem.
huh?
Chem. We who believe in chemtrails pronounce it chem.
Okay.
CHEM trails.
no.
Okay.
We've been bringing them in for years. Not kidding.
Yeah, and now people are gonna say, "I knew it." No, the chemtrail crowd can't accept that there's all these contrails, and they say, "Look, this is how it was in the 1990s, and now look at the sky, all those chemtrails." No, actually, the increase in flights, the increase in commercial air traffic is gone up exponentially since then. If you get on Flight Radar 24, and you can do that online too, and you don't have to log in to see it. You can just go and see all the flights that are currently in the air. There are thousands of flights in the air right now as we speak, and there are several main corridors. There's corridors out of New York, and out of New York they go to Copenhagen, to Oslo, overseas, into Italy and so forth. And there's just these big ribbons of planes going across the ocean. And once they get up to 30,000 feet, they start making a contrail. Below that, they don't make contrails typically, unless the weather is really strange. But the truth is that these guys are very these plane engines are very efficient, and they actually, because they're so efficient, much of what comes out of their back end is the hydrocarbon burn products, but far less of them than there used to be. And when it interacts with the water vapor in the upper atmosphere, you'll get a contrail. And it depends how much water vapor is there. I've seen contrails that start off, then they stop, then they start off again, then they stop for a while, then they start again, like dashes in the sky. And people say, "The pilot's turning on the chemtrail machine." Okay. And people love to say chemtrails chemtrails are persistent. Contrails aren't persistent. Really? In what world do you live in?
Right.
Contrails are not only persistent, but they can go all day and all night.
Right.
So it's possible. Now, as OG Skywatch says, people talk about cloud seeding. Yeah, that's a real process that was used, but it's not done. Oh, Tom, it's okay. We're kidding. It's cloud seeding was done to see what they could do about initiating weather changes as needed, and it actually wasn't very successful.
Right.
So it's something that I don't think we take it we actually consider a lot of the time, is that people are making chemtrails in the sky. There's really no evidence whatsoever of that. They just say, look up, it's all over the sky. Yes. There's contrails up there.
It's
There's
everywhere.
contrails up there, you know. And what happens is these are people generally that don't understand contrail science and don't want to, because they would rather have their narrative rather than understand the science. Because if they understood the science, then they'd have to say, well, I could be wrong. And heaven forbid they're ever wrong. So, that said, enough of the soapbox for me.
Yeah.
Yeah.
Oh wow.
Yeah.
Poke the bear. Papa Tom poked the bear.
Oh, it's okay. You know what? I don't have a problem dealing with people that are being difficult on purpose. Okay, it's like the flat earthers.
Yeah.
I have no mercy on.
Oh,
I have no
no,
mercy
no.
on flat earthers, and I'm not. I make no apologies for it. You know, the only way I make an apology for it is if the person is truly not knowledgeable of the science, and they talk to a flat earther first, and they start believing it. Those are people that are being lied to, and it gets me angry and incensed that people would lie to other people about stuff like that, you know. And because I say they live life, that the flat earthers live life in a science-free manner, and when you're science-free, you can make up the rules of the universe any way you want.
Agreed.
Yay!
Right.
Let's make up new rules. Earth is flat.
But unfortunately, as we've seen, I mean, it cost a couple people their life, or one person in particular. What was his name? Mad Mike, who the
Mad
rocket
Mike
guy.
Hughes.
Yes, cost him his life.
Really?
He was building a
Steam
rocket
powered.
to prove that the Earth was flat. A steam rocket.
Yeah.
He shot himself up there, 5,000 feet or something, and his parachute.
Actually, it failed seconds after launch. Now, as he launched, you saw the parachute release and rip to shreds. So now, if he knew that, he knew all the way up that he had no way to come down. And he just crashed into the desert floor, and he was Wile E. Coyote, you know, walking away. But he didn't walk away.
No, he definitely is flat.
Yeah,
Earth.
he proved it. He proved that humans could be flat in the Earth. Yeah.
So bad.
Yeah.
So bad.
And so the other thing that's interesting about that is before he did it, I kept saying, this guy is committing suicide in front of the world, you know, and in a way to try and kind of influence him not to do this. I literally took his rocket picture with him standing so proudly next to his steam-powered rocket, and I used Photoshop to put in on the side Bill and Ted's Funeral Services as a sponsor. Okay, and I put that like it was painted on. It looked very, very real.
Oh, God.
Bill and Ted's Funeral Services. And that was like a month before he decided to launch himself into history. Yeah, so all right, well, whatever, you know. If you're going to do stupid stuff, prepare to die stupidly, and he did.
Right.
You know? Look, everybody liked Evel Knievel, but everybody wanted to see him crash. That's why they watched. Let's watch Evel Knievel. Let's see what he breaks this time. You know? The Great Caesar's Palace jump where he broke both legs, shoulders, arms, back.
Yeah, that was
you know?
Remember that.
Oh, gosh, that was just terrible.
Yeah, it was.
But...
all for, fame,
but
you know what I mean? People do really insane things for fame.
But you couldn't take your eyes off it, could you?
Right.
It's like
because, I mean, that was the thrill of it, though. Is like, people don't watch them for the success. People watch these people for the failure. Right. And that's kind of morbid.
Yeah, it is. And why do people watch NASCAR? Because they, some people want to see it. Who's going to win? You know, who's going to win? Who's going to win? Other people watch because they say, I want to see some cool crashes. It's like, yeah, at those speeds, do people realize how little it takes to kill you? You know, ask Earnhardt. He hit the wall in a way that didn't even look like it was. It looked like a nuisance hit. However, just the way he hit the wall was enough to kill him. And I thought that was just wow. That was incredibly surprising to me, and I felt bad for him, you know.
Yeah.
Hey, Flames of
Yeah.
Wars with us. How you doing, Cynthia? How are you, Cynthia Clavey? How are you? Yes, this is the Horsehead
All right.
Nebula here, Cynthia, and I'll show you these two nebulae. The red and the blue. These are the primary colors of the universe that we see. The red is ionized hydrogen gas. And as an astronomer, which is what I am, that's what I went to school for, okay, and this is what we look like. This star here is illuminating some of the gas in here, and dust rather, but it's also causing ultraviolet energy from this star to be absorbed by the hydrogen atoms in here. And when that happens, the electrons bounce off the atom and then bounce back in. And as they come back in, it's called recombination. They give off light as they give that energy up. And that light in the hydrogen case is red. Okay? The blue, on the other hand, is a very different process. Here, the stars aren't hot enough to send out a lot of ultraviolet light like these stars to ionize hydrogen, like here. But what they do is they just send out their light, which is red, orange, yellow, green, blue, indigo, and violet. So at the end of the spectrum toward the violet, those are very high-frequency light photons, and those light photons are actually just perfectly made for the little dust particles that you see in here. See this brown little tongue of dust? Another one here. This is all a gigantic dust cloud in here, known as the Orion Molecular Cloud Complex. And this star's light is being scattered by the dust in here, and that makes it sky blue. Same reason our sky is blue. Our molecules in the atmosphere are scattering starlight from the sun. That's why when the sun is on the horizon, it looks red. And when it's overhead, it looks sort of whitish yellow. Okay, when you're on the horizon, from your perspective, you're seeing it through more air. You know? So that's pretty cool. This is coming out really pretty. I'm liking this. And let's yeah, it is pretty. And this is the Flame Nebula up here. And I purposely have it just off the view, right?
Yeah.
So we're going to save this. I have it labeled as the Horsehead up here, the Horsehead Nebula, and for obvious reasons. Okay. Let's see what it wants to do here. It's going to probably take down this brightness a little. And I'm going to actually bring it up. I want to see what else is here. Okay. So you look in here, you can see that there's actually detail in here that we're not really catching right now because I'm keeping the noise level down visually. But I don't have to. I mean, I could really crank this up. Like to show you what's really here, you do this. Okay, and this guy over here, all right? And so now you see even more detail in here in this whole area. And if I color correct it one more time, now you see that there's the color correction. Now you see the ionized hydrogen glowing. It goes all the way out here. It goes out there. It's massive. And you can see now that it has a reddish glow in this dust. That's because, as I said, the hydrogen gas is mixed with the dust. And so because it's mixed, you're going to get ionization, and you're also going to get the dark dust as well. So that's cool. So we'll let's drop that back down.
Is that noise there, or is that like those streaks?
Oh, that's actually momentary. It just has to do with the way the screen is being sent to us from the observatory. It's not in the photo. Yeah, once it's gets redrawn, it won't have that in there.
Okay. No, I was wondering if like a couple more satellites zoomed through.
Oh well, there's one there. Yes. And
yeah.
there's one there. Okay.
Okay.
Yeah. So that's cool. That's pretty neat.
Right
yeah.
on.
So let's pull this down a little bit, and
that is very. Oh yeah.
And now as we soften this up, it should be a little better. Oh, look at that. That's beautiful. Look at all this subtle detail in here.
Okay.
Then we have more dark up here. That's actually more dark nebula up there. All these dust, you know.
That is gorgeous.
Yeah.
Wow. Because you see, if you're looking at Tiff and I, we're looking at the 60-inch television while looking at the chat on our phones while in front of another television. So we're like looking at all these different angles of all the just amazing views.
Oh, it's really cool. I mean, I can't stop looking. All right, I'm going to save this now, and you'll see across the top it says it's saved. Now that FITS file, that's an astronomical file format, and then I'm going to save it exactly as seen, and then you'll see a PNG file. Okay, so right now as we speak, what's going on is the images that I just saved are heading out up to Earth orbit and then down to a server where they're going to be stored on the server for you to see probably within about 35 seconds. Okay, and where's that server? Well, you got to just go here, skytourlive.org, and scroll down to the entry that says show us cool pictures. Take me to the cool pictures, and bam, that is going to be where they're located. Just read the instructions on how to get to them. Curtis Horn says, are you taking a trip next week? Yes, I'm going to be leaving Tuesday for Arizona. I'm going to be here in the building. I got to install an all-sky camera because we have one, but it's black and white. It's low resolution. I'm installing a color one, very high resolution. You could zoom in on and see that the Orion Nebula is there. You can't see that on this current one. And it makes star trails every night, time-lapse every night, a kilogram, which shows you slots all night long, every hour, and it has a average picture for the hour to show you whether it was starry or cloudy. It's pretty cool. So now let's see. Cynthia said something. I think I heard the rings around the stars can be Yes, Cynthia says, I think I heard that the rings around the stars can be post-processed out. Exactly. These are rings that are artifacts of our very fast system. This system here, this region, this is all faint dust in here, okay? And look at our exposure time, 25 seconds. And we only have a 10-inch telescope out there, but our camera's at the front end of the telescope.
For now, only a 10-inch.
For now. Yeah. And it's actually running. If we didn't modify it to have the camera at the front end, this would be an f8 telescope if you're familiar with photography. However, we added a camera at the front end with a lens that collimates the image. And so we sidestep a whole light path with this telescope. Bottom line is, we're now running at f2. The telescope's running 25 times faster than it did when it came out of the box. So this is really cool. And these ring artifacts we do process out, and we're actually quite successful at it, because what we do is we separate the stars from the nebula, and they usually are on the nebula side, and so we get rid of them on the nebula side, and then we put the stars back in. It's really pretty cool, you know. Now, of course, some people like the rings, and Old School just said he does. That's funny.
It does. It looks. I want to say like mystical, or even like whimsical, or even like heavenly.
Oh yeah, I can see that.
How else to describe it? It's just really beautiful.
I'm going to do one more exposure here, and then we'll move on to the next object. All right. So
it looks like a blue howl from 2001. The top star.
You know, I worked
in this screen. It does.
I worked with Douglas Trumbull, who did all the visual effects for 2001: A Space Odyssey, and Doug designed HAL. And we did a movie, and he asked me if I wanted to create HAL 2 for the movie. So I got to design the new HAL, which was very cool. And this time, HAL was binocular vision, had 2 lenses with light inside. So it was really cool. Very, very cool. All right, so I'm going to take us out of here. I save those. All right, we're going to pop out of this. We're going to go back to our basically our Finder view, which gives us It's a 1 second exposure of this region. All right, there it is. All right, so now we go to our other aspect of this, which is our planetarium view. And this planetarium view shows us where we are in the sky. But before, we're not going to need this yet, because what I'm going to do is I'm now going to take us up a little bit. And this moving up is going to bring Alnitak down to the bottom here almost. And we're going to see the Flame Nebula right here. And these two images can go together. All right, so we'll do that right now. There we are. Donald Kunzer says in the 1955 movie, When Worlds Collide, there are photo plates with ringed planets. Yeah, that's true. Ring stars, I'm sorry. Yeah, that's true. Yeah. Does anyone remember the planet's name that was going to collide with the Earth? Was it Belarus or something like that? Belarus? Okay, there we go.
It's been so long since I saw that film. I think I saw it as a kid. It was like on Elvira.
Yeah, it probably was. Yeah.
Right.
Zyra. Donald Zinal says Zyra. Yeah. I remember the little calendar on the wall, time to Zyra or whatever it was, and it had a countdown. That's what you want to show a human race is doom, to show them a countdown timer to their deaths. Boy, oh boy, that just makes no sense.
A lot of films do that. You know that?
Yeah.
I think Deep Impact did that.
Oh, did they?
Yeah, there was a timer for that one. Yeah, because it did a bit. Oh, Don't Look Up did that as well. That Netflix film about the asteroid.
Leonardo DiCaprio was an astronomer.
Yeah.
He had glasses like me, had a little beard like me. He looked like J. Allen Hynek, which I've been accused of looking like at times. Okay, I'm going to live stack this now. We're going to get rid of the horse head, which you'll see here in a moment. It'll come up and it'll stack, and we're going up to look at this now. All right, so we'll clear this. All right, and the next photo will come in, and that will start our series for that.
Very cool.
Rockstar's with us. Hey, man. Carl Becker, how are you? I see Carl Becker. I saw you earlier, and I meant to say hi, and I didn't. I apologize. Yeah, no.
Oh, some SpaceX news I can share with you guys. I forgot. And hopefully, Mark, if you're able to, this Wednesday, I don't know what you have planned this Wednesday. Is it the 14th on Wednesday? Anyways, March 14th. We are told
Thursday.
That
I think that's
Thursday. So we're told that the third launch of the third test launch for the
Starship. Excellent.
will take place that day. Yeah, we're actually going to stop production and watch it.
Nice.
So
it's not going to wake me up at 5 a.m. again?
I might. If you have your sounds on your phone, ring you.
Here we go.
Watch it.
Look at that.
Get on YouTube.
This is beautiful. Now, I brought it down this low so we could capture these reflection nebulae, these blue nebulae that have stars that are having their starlight scattered. There's Alnitak and the Flame Nebula. And that's not Starlink. Okay, just so you know. It's a 25-second shot. So in 25 seconds, it moved very slowly. And then it moved a little further in this second exposure we just did. All right. Yeah, this is pretty.
Not my fault.
Not this time. Don't worry. I'll be blaming your butt when this happens again. I want to say hello to Mindfork. That's Chris. She's here. Hi, Chris.
Oh, yeah.
Nice to see you.
I saw her earlier.
I will be at Contact in the Desert along with these two down here, Mike and Tiffany.
Contact in the Desert.
Yes.
Oh, yeah. It's going to be a lot of fun.
Well, yeah, I'll be there. And that's early June. And then
we're going to be giving away some of these.
Oh yes, that's right. The binoculars. Yeah. Let me increase the size here. Now you're up. Now you're large on camera. So make sure your hair is combed.
Don't
We're
be
gonna give
breaking
away
it.
some of these.
Oh, look at that. Yeah, the Star Sense telescopes. Yep. Gonna give away
All
telescopes. Yeah.
right.
See,
This is not the one that you'll get. Don't worry. This is a beat up one.
yeah,
that
that's
The
a
beat up
demo
one.
model.
That one.
That's just a demo model.
Excuse me.
Just a demo model.
Uh,
It is not beat up.
oh, not beat up. The box is beat up a little bit.
Because
It's a demo model.
Mario
A demo.
start following Mark too, and hopefully he's not watching and he didn't hear that.
Mario, next time put the tube on the correct way,
Oh.
please. If you're watching, Mario. All right.
Daisy and Zoe Amethyst say that this nebula, in spite of your telescopio words, this is one of their favorite locations. And if you notice, we're catching a lot of detail out here that we don't often catch, and that's because the camera we're using is specifically tuned to this particular telescope's focal length. We're getting the right amount of what are called arc seconds of distance on the sky per pixel. And that's really, really important because arc seconds per pixel, having the same or having the right number of arc seconds per pixel is really important. And we actually have 0.98 arc seconds per pixel on our camera. So we have exceptional views with this camera setup. Jessica S. Hey there, how are you?
Hi, Jessica.
Daisy and Zoe, you got to remember, go to skytourlive.org when we're done and take down this photo. The more we expose, the more this satellite line will go away. This is actually a tumbler. How do I know that? Okay, Mike, this is a test. How do we know that this is a tumbling satellite, Mr. Starlink?
I can neither confirm or deny.
Ay.
Oh no.
How do we know that it's tumbling? I believe it's because you have the light and the dark. The light and the dark. It's kind of
Yep,
like
it's the aspect ratio is changing. At one point,
Yeah.
it's like this, and so you see it, and then it tumbles this way, and it's a darker line, dark if not visible, and then it does that same tumbling, and it does it periodically, as you can see, and based on the length of this line, okay, and the exposure time that we took, I can calculate how far away it is and what altitude it's at.
Oh,
Yeah.
very cool.
So I wrote a little thing in Photoshop to allow me to measure the lines, and I convert them to arc seconds, and I wrote a program which tells me how fast it's moving at that altitude and what the altitude is. So, and that's all just celestial mechanics, just like stuff we do to calculate how these things move in the night sky. And I do that to keep my brain engaged.
That's right.
Yeah.
Very cool. That's
Color
very
correct
cool.
now.
Yeah.
Let's see what it looks like. Look at that color correction. Brings out so much more detail.
Right?
Yeah. Now what's funny is until I got this camera, I didn't see these blue reflection nebulae like we do here. So it's pretty cool. And Charles Smar is with us. Hey Charles, what's going on, man? I haven't seen you for a long time. Genghis is with us.
Hey, Genghis, what's up, my bud? Genghis Khan.
Yeah.
You're my dude, man. You're my dude. You know what I'm talking about.
Oh, Ricky Ricardo. Oh man, how's it going?
my life bad watching this on cell phone.
Yeah.
Yeah. We've all been there. But it's still really amazing. It depends.
Yeah.
I mean, I'll just. You probably can't see it, but that is an amazing shot on my cell phone.
Mm-hmm.
Wait, let's increase the size. Let me see it again.
There you-
Oh,
There you
very
go.
cool. Hey, that looks like that's our stream.
That's us.
Very cool. Yeah, so Carl Becker asked a question about whether the telescope is moving in between. It's as Charles also mentioned, it's following the Earth very slowly, and the Earth is rotating to the east, which means that we're rotating out from under the stars, and they appear to be going to the west. So the telescope is turning ever so slowly toward the west as the Earth turns to follow the stars, which are going to be setting as we rotate out from under them to the east. So that's pretty cool. Look at this, pretty good. 14 exposures.
When you think about it, like our solar system is moving through the galaxy, right? And our Earth is moving around the sun, but then you have these little satellites moving with us as we're moving through the galaxy,
including the moon traveling around us and around all the other planets.
Yeah.
It's just amazing when you think about it. It's just amazing.
Yeah.
We're all just
the ingenuity involved in having these satellites continuously following us through the galaxy. It's really
If you actually saw the actual path that the Earth takes, it's not intuitive at all. You think of it as a circle around the sun, right? But the sun's moving. So what's actually going on is the Earth is making corkscrew paths through the universe as it goes. And that's the thing that makes people crazy when they see it. They go, how does that work? If you account for all the motions, it's a corkscrew path. Yeah.
Right.
Boy, this is really something. This is coming out nice.
Yeah, it is.
I really like that one.
Let me do another color correction here. And let's try to just sneak a little more darkness into the background here.
You know, that could be a contest thing
There we
too,
go.
like putting one, like if we were to capture that off, like get a really, really nice one, and then put that on metal, like something like this. And then we can give that to somebody for like a contest.
I think that's great. You take
Right? Something like this.
yeah, look at that. That looks like Merlin engines there.
These are these Merlin or Raptors? I can't. Oh no, no. This is on Starship, so I think these are Raptors.
No.
Yeah, I think these
Well,
are
then
Raptors.
Falcon 9.
3 Raptors. Falcon 9 uses the.
It
Merlin.
does?
Merlin.
Yeah.
Okay.
Yeah. Or Falcon Heavy. Oh my goodness! Now I get them all confused. We have three different ships.
Get your
One of them-
garbage together.
I know, right? I think it's the Falcon Heavy that uses the Merlin,
Okay.
and Falcon 9 uses the Raptors,
All right.
or are they interchangeable? I'm gonna have to.
Hey, I know. Look it up online, Mike.
Yeah, right. I'm giving people bad information. I'm so sorry. I can neither confirm nor deny.
See, guys, even someone that works at SpaceX like Mike, okay, can't always have full command of the facts because sometimes the facts are changing. The targets are changing.
They do. I mean, we did use Merlin engines on Falcon 9 at one point, but I think because should I be saying
No,
that?
say nothing.
Okay, that's all. There's different types of Raptor engines. I can say that.
Yeah.
Because that's actually out there in the press. There's 2 different versions. We're no longer using version 1. We're now using version 2, and those are the ones that are way more adaptable when it comes to fuel efficiency and like all the other. There's like a lot of stuff there's a lot of components that are no longer on that engine. More streamlined, let's put it that way. There, that's all I can really say. I think. I hope. Boss, please don't fire me.
When in doubt,
Micah,
say nothing.
watch me. Right. I'm so in trouble for this one. Okay. No, I'm pretty sure this is all
Public stuff.
Yeah.
That's
Well, it certainly is because when you listen to people talking, you'll hear the announcer say, "Well, look at those Berlin engines firing up. Oh, go! Everything looks wonderful."
Yeah.
Right. Oh, that
Yeah.
guy. That guy works at my facility in Hawthorne.
I think that's
Yeah.
cool.
Oh yeah.
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 They're up there on the second floor.
Yeah, I really like his enthusiasm. Now see,
Yeah.
the Merlin vacuum engine is actually on the second stage of the Falcon 9. So maybe
Thank you, Cosmic. Appreciate that.
Oh, so you're
Yeah, Falcon uses Merlin, and Starship uses the Raptor. 33
Yeah, see,
Raptor.
he looked it up for you.
But I knew the answer already.
Well, he was
I had to
helping you with his confusion, with your confusion.
Thank you, Cosmic Ray. He had my back. Thank you, Bert. Thank you, sir. Much obliged.
All right.
Really? I can't say much obliged.
Why can't you?
No, it's an inside joke.
Oh, okay.
I know. Right
Much
now.
obliged. Huh? Much obliged.
Oh no.
We're gonna have to. Sorry. So this is an amazing shot of the Flame Nebula. Let's continue.
We are.
Thank you.
Yeah.
I can neither confirm.
Okay, you folks in the chat, feel free to ask the questions you're actually thinking of asking right now to Mike, because we can see that he's just having way too much fun. Okay, and he's got the giggles. See, like he's doing this fanning himself because that makes you stop laughing. Not. Yeah.
We had to mute ourselves.
It's okay.
Ugh. There you go. All right, we're good.
Yeah, see, Kevin Williams, how dare you make an absolutely valid observation? If the Earth is flat, would the satellites just keep going into space? The answer is why, yes, they would. So therefore, if you believe I know you don't, Kevin, but I'm saying someone who believes in the flat Earth would actually have to figure out a methodology. So guess what they say? You ready for this? I'm going to tell you. The GPS satellites, right? Well, they're at geostationary positions. So they're over the same spot on the Earth, like the television transmission satellites. But how are those done on the flat Earth? With a straight face, they'll look you in the eye and say, they're on balloons. They're being slung under balloons. And you think I'm kidding? No, I'm not kidding. I'm just astonished by the lunacy of the people that believe in a flat Earth. I have like dozens of counter proofs, and I'll give you a simple one that they can't answer. They cannot answer. The constellation we're looking in is Orion. Let's go to our planetarium program for a second. Okay, so here's Orion. Do you see it? No? Let me help you. Okay, so there's Orion the Hunter. Okay, here is Betelgeuse, and here is Bellatrix, Alnatak, Alnilam, and Mintaka. We're currently looking at Alnatak. And then we have Saif, and we have Rigel down here. Now, this is the view from the northern hemisphere. All right. Now, if you go to the southern hemisphere, what does Orion look like from Australia? It's upside down.
Yeah.
So if it's upside down and Betelgeuse is on the bottom, all right, Betelgeuse is going to be in the bottom right in Australia. Well, the flat earthers can't explain how that can possibly happen. They don't have an explanation for why that's true. See? So what they do is they literally go as far as to say literally inane things like, well, it's just a projection. And the stars are not nearly as far away. In fact, to make this work, the sun has to only be a few thousand miles away. Right. And it has to be a spotlight kind of a thing, so you don't see it. Okay, let's assume that's true, all right? If you look at the sun when it's on the horizon, you measure its angular diameter, it's going to be half a degree. Now, that's when it's on the horizon, coming towards you in the flat earth theory. As it gets closer, it's supposed to get bigger, but it doesn't change diameter
whatsoever. Right.
So how do you explain that? Well, they can't explain that, and they won't. They'll just,
right.
You mention that, and you mention Orion's upside down, you mention the sun's angular diameter doesn't change, and they're like, I want a cake, something stupid. They go off like the deep end because there's nothing they can say to it. They're science free, people, and Some are
Science
yes,
free.
yeah,
Like
they're
sugar
science
free.
free. If you're science free, like sugar free, if you're science free, you can make up the rules any way you want, right?
Right, which is very disconcerting, especially if people don't. People that listen to them don't understand what they're listening to, and then they just go with it because they sound science. Actually, Donald had a question for me. It says, "Will the next Starship test deploy any payloads?" No, it will not. We want to make this test is to see if Starship will make it to orbit and beyond. So that's what this one
Is this going to be? When is that test? Do you know?
March 14th.
Okay.
Don't know the
All
time
right.
though.
But that's going to be
Yeah.
a flight to orbit with Starship for the first time.
That is we're going to do the second stage hot staging again, and I think it's supposed to be more efficient. I think they did something with the first stage and second stage where it connects. There's this not foil, but there's these vents in order to not burn the first stage or the first stage. But that hot staging will occur, and then it will hopefully reach orbit.
Excellent.
And the I think both of them are going to splash into the ocean, but they're going to attempt to land in the ocean.
Okay.
They're going to do the belly like the Starship or Super Heavy is going to do its belly flop, and then it's going to fire up its engines again, but not land on land or land on the ship drone or the drone ships that are in the ocean. It's going to attempt to land on the water, but obviously it's going to splash in the water. And then I believe Starship is going to land somewhere in the ocean. Probably, I don't know where though. Actually,
Okay.
I'm not sure. Last time it was supposed to land somewhere near Hawaii. It was supposed to travel across.
Where is it launching from?
Texas.
So Boca Chica.
Boca Chica, Texas. Yeah.
Okay. Well, next time I talk to Elon, I'll let him know that you're being very informative. I think that he'd like to know that.
Wonderful. Yeah, I'm in a lot of trouble.
Right. Cynthia Clavey says
I
well, read her statement
don't-
so folks can hear, because some are just watching and not reading the chat. What'd she say?
Oh, she said I heard a blurb that they wanted to open and close a door. I have no idea. Yeah, I can't confirm
There
or
we
deny
go.
that. No, really though, I'm not sure about
Right.
that.
Excellent. So this is
And rotate and create artificial gravity. That I'm not sure of either. They just want to make sure that the heat tiles work. They want to send it to orbit, so when it does come back, they want to make sure that all those heat tiles keep the structure shape, the ship safe.
yeah.
Doesn't burn up on reach.
Now, little by little, they got to do little things at a time. Unfortunately, because if they have a process that spins up the Starship to simulate, say, a gravitational field, that could mess with a process that might otherwise work fine, and then it gets screwed up, and they may not know which caused what. So that's why they've got to do things separately in order to make sure that each particular discrete task is functional and working properly. So check this out. Look at this. This is the Flame Nebula. Now, when we look at the Flame Nebula, one of the things that's interesting is we usually see in a telescope, this is what you'll see. It's going to look kind of like that, okay? You'll just see kind of that much of it. And then in bigger and bigger telescopes and better stuff, better optics, you can start to see a lot more. And right now, we're actually seeing tons and tons of detail in here. Look at all the stuff out here. Beautiful feathery stuff. This is going to make a beautiful photograph once processed.
Yeah.
Oh,
Yeah.
And we'll get rid of these halos as well.
Right. That's just an amazing shot. I can't even imagine what it would be like to even traverse the sky like that in space. You know what I mean?
What are you talking about?
Like, I mean, it's kind of I don't know. Like, you ever watch like an episode of Star Trek or something, and they're traveling through space, and they're in the distance, they're like, "Oh, we're about to enter this nebula." It's not like that at all, obviously, but imagine.
Yeah, I mean, if you were
Like-
flying into, let's say you were going right into that spot right there, okay?
Right.
Let me even say directly. Let's say you were flying into here, okay, right in that red
Okay.
square, okay? As your
Okay.
ship was flying into that red square, it's maybe 1,500 light years away or so. You're seeing it from far away, so you're seeing the aggregate of all the light coming from these ionized hydrogen atoms in this little square. But as you get closer, this little square becomes light years in size. And like as an
Right.
example, okay, let me show you something, because I did this calculation. As we zoom in, right, and we get even closer, and I'll do it. Okay, you get closer and closer and closer and closer and closer. Okay, you get to a certain point where you start to see the square pixels. You see those square pixels? Now, at 1,500 light years, those square pixels will correspond to perhaps a number of solar systems. But for the Rosette Nebula, that's 5,000 light years away, each pixel corresponds to 5 solar system diameters. Okay? This is closer, so each pixel corresponds to less, maybe 2 solar system diameters, or 1 3/4 solar system diameters. But when you get in there, you won't even see this glowing hydrogen. It's gonna not be evident to you because you're not seeing it from far away. On the ground, if you look up in the sky and see a light cirrus cloud, a feather cloud, when you go into it, you may not really tell you're in it because it's sort of all around you, and it might look a little bit lighter, but you're not going to see it with the definition you see it from the ground. And that's kind of what we're going to see here. If we went to this location, that's what we'd see. So these are massive, massive features, and because they're so massive, they're not going to look anything like what you see there if you went there. If you went inside this dark nebula right here, okay, the heart of this nebula, what you might find is the star that's causing this nebula to glow. Okay, in part. And you might also find that once you're in there, that you still see all the universe like we see it from here, and you won't see the flame nebula like giant all around you. No, you'll see it's very, very subtle, incredibly subtle from that position. Yeah. Hey, Puck Elf, how are you?
It's really fascinating.
Zoom in the like button until it pixels itself. That's funny. Yeah. So as you can see, the more data we get, the softer and more detailed the image
I agree
becomes.
with you.
And I went to full screen here just to kind of show you the beauty of what we're seeing here.
Absolutely.
Now the telescope is guiding, so that's what this is down here, this band. Okay, if we zoom in on just the band here, okay, I'll move up. Okay, this is the corrections. The telescope is slowly moving slightly to keep the stars round, and so this is wasted image, and we'll cut that later. We'll cut that off. Okay. Yeah, and it's kind of weird to think about this, but think about this. Okay, you look at all these stars in here, all these stars. So look at that one tiny star right there. For all we know, there could be a star system around that star, and for all we know, there could be life there. Now, I think that life in the universe is the rule, not the exception, to be honest.
Agreed.
And I feel that way because of the nature and prevalence of carbon in the universe,
Right.
It's the fourth most abundant element, so it stands to reason life would be generated with carbon. You know. All right, let me bring back the telescope here. Okay, move that over. There we go, and then let me bring back our stack and dock it up to our thing here like that. There we go. All right, so we've got 46, and I'm going to save it, and then we'll save it again at 50, and then move on. Save exactly as seen.
Did they recently find carbon on one of the what asteroid did they go to? Ah, man, I am so
Bennu?
behind. Yeah, did they not find carbon?
Oh yeah,
on that,
no,
on
there's
that element?
carbon on a lot of the asteroids actually, and so it stands to reason too. You know, now here's an interesting thing for you. See all this dark nebula here? Okay, we look at that dark nebula and we see it's everywhere in the galaxy. It's a lot of places in many other galaxies too. But you know how much the dark nebula makes up in terms of the universe? How much it's in the universe? How much of it's in the universe? It's like 2%. And
Really?
that's it. That's actually a fairly large amount.
Yeah, but still, I mean, 2%.
Yeah.
You would think it would be more. No?
Earth Radio is with us. That's Ronald. How you doing, Ronald?
Hey, Ronald.
I've been listening to some of your chatter sessions on Earth Radio.
That's
Hopefully your website is back in business. Donald Kunzer says solar soot. Yeah, stellar soot. You know, I mean, we get that too. It's not just from the sun being solar because it comes from its name, Sol, S-O-L. But yeah, stellar soot. You know, Betelgeuse is famous for stellar soot. In fact, part of that stellar soot is probably why it dimmed like it did in the last few years. That crazy dimming it was doing kind of led us all to believe that we're going to start to see neutrinos, which are a precursor to supernova. But we didn't see neutrinos, and then it started to get bright again, which means that it probably puffed off this bubble. And see my hand here? The star is making all this stuff. It has these really weird bubbles on its surface, bubbles of material, some of which is dust. And it's because if Betelgeuse is where the sun is, those dusty regions would be out past or just about to the orbit of Jupiter. So it'd be colder in those outer regions relatively. Still hot, like 3,000 Kelvin. Okay. But it would actually be puffing off this soot so that when it left the star and cooled, you see where my hand is? It would actually become somewhat opaque, more opaque, and thus you wouldn't see the star very brightly. You'd be seeing it through a veil of this dust. And we think that's what happened with Betelgeuse, because it slowly started to brighten again after that dust apparently moved off the face, as seen from our perspective. So, pretty cool. All right, we're going to save this now. And
Excuse me a second, Mark. I'll be right back.
no worries. All right, and we'll save it just like that. Good. Now we can move on to the next item up for bids. And let me see what Puck F is saying here. Hang on, let me just go to this and go to our 1 second view. Extrasolar, he says, is a good word. Means outside of our orbit, outside of our solar system. Yes, exactly. Rocket City Astros with us and Blues Traveler. Hey guys, how you doing? Good to see you. Yeah. Oh, Ronald, that screen for your chatter sessions is kind of fun. I see that you see the Dolby noise thing going up and down. That's pretty cool. Michael Hendricks with us. Hey, how you doing? Yeah. Rocket City's going to be live streaming the solar eclipse. I'm going to be teaching a class on the solar eclipse, so I won't get to do it, you know. By the way, I just want to let you guys know, the West Coast Observatory here, I'll be out there Tuesday installing the all-sky camera. The all-sky camera is actually en route out there now. And then here on the East Coast, besides a second observatory out west that we're actually putting in fact, I'm going to see a site next week out there for the potentially for the second telescope. But a third telescope system is in the works. We're actually planning on doing and putting in a solar telescope facility, and that'll be here on the East Coast. So we might be able to image the flares and prominences on the sun, and I mean that'll round it out, won't we? Well, it'll round out our astronomy so that I don't get any sleep. If the sun's up, I'm gonna say, God, I got a dream. You know.
Oh man! Speaking of sleep, I'd be in bed already if it was a weeknight.
Oh, that's true. It's Saturday night. That's right. Yeah.
Yeah.
All right.
Oh yeah, guys. I like my days are like this. 2:30, I'm up. I'm at work by 3:30, 3:45 ish, and then I'm waiting for everybody else for like an hour to come in.
That's right. You sit in the parking lot.
No. That au contraire.
Oh.
I actually go inside and I get stuff ready for the people to come in. I get blinds ready. I'm trying to move up in the way. What I'm doing is I'm learning all the lines because once I learn
moving on up
my calibration
to the SpaceX side.
Yeah, that's the plan. Either that or Tiff and I were actually talking about going up to Washington. That might be in the cards because we'd be actually building the Starlink satellites themselves, the ones that go into space.
Wow.
That's where that whole setup is. So I mean, we have a lot of options. Tiff. For those of you who don't know, Tiff is a biologist, or excuse me, a scientist that deals with. I'll let you tell it, baby. Go ahead.
We our side, we formulate antibodies that detects cancer in patient biopsies.
Oh.
Within 24 to 48 hours.
Yeah.
Right. Mm-hmm. So it's revolutionary science where and life-saving science.
Wow.
If a person is worried about a lump or something that they might have, they can go in, get this test done, and they can find out instead of waiting weeks, sometimes months, for their test results. This in 24 to 48 hours, they can find out if they need treatment or if they're fine.
And Tiffany will do a lumpectomy. Oh, maybe not. I used to work in a pharmaceutical lab where I was creating software for scientists to use to do assays.
He was part of Big Pharma.
I was.
So
I was only consulting there. And then when I discovered that they were using small dogs, beagles, I kind of lost it and I couldn't do it anymore. Yeah. And I asked to be removed from the project, and they eagerly agreed.
Tiffany's.
I'm on the same boat as you on that because we deal with goats, rabbits, and mice.
Yeah.
And I'm not too happy about that.
Well,
we recently found out how they're treated.
Yeah. See, the problem I had was I saw the beagles, and they had their heads shaved, and there were electrodes in their brains.
No.
Okay. And the rhesus monkeys. Okay.
Oh, no.
Tons of rhesus monkeys that were in various states of experimentation. I wasn't supposed to go down there. They told us never go down into the basement to these chambers. And don't tell me to never do something. Because then I'm like, I'm going down there. Yeah, and I found that out, and I told a lot of people that was just, I couldn't accept that. And they said, well, you don't have to work here. And I said, you're right.
You're right.
So I asked to be taken off the project, and they said, wow, you're very profitable for us. Yeah, at the expense of beagles and rhesus monkeys.
Right.
Yeah. Oh, and mice. Yeah, they had the mice thing going on too.
Yeah.
Okay. This is another nebula we're pulling up on right now. It's right there. I can see it. This is a really, really beautiful nebula. I used to think of this as kind of a dull, boring nebula. And then I started taking pictures of it with this camera, and the world changed. This thing is so gorgeous. So I will show you now what this is. This is a really pretty nebula. It's an example of, again, dark nebula with reflection nebula. You know, the dust particles that are scattering the light from the hot blue stars in the area. And ionization nebula, that's called an emission nebula, where the hydrogen gas is actually glowing. All right, so let's do that. And remember, our last object we took pictures of was the flame, and when I do this, it'll go away. So we've cleared the stack now. Yeah, okay. So here goes. Let's hope that this one comes in just fine. The wind tends to pick up later on in the evening out there. So if we see the curve, there we go. It appears. So now, there we go. This nebula is called the Flaming Star Nebula. I actually haven't taken a picture of it for, oh gosh, many months. You know, but it really looks nice. Maybe if I could spell this right, it would be okay. There we are. It's an emission nebula, which you see by the red glow. It's a reflection nebula, which you see by the blue. And it's a dark nebula, as seen by the dark tendrils of dust inside of it. It's got everything. It's got something for everybody.
That is amazing. Yeah. It's just massive. It's a massive, massive structure.
Also, if people are interested in supporting us, you can check out our Patreon at SkyTourLive.org. You look up at the top and it'll say SkyTour Livestream, which is this stream. The Patreon. We have $3, $5, $10 subscriptions and higher. And depending on what you come in with, we could give you and will give you the highly processed finished images. These are the raw images that we save, and you get those for free. Look at that. So if you want those for free, those are going to be available at skytourlive.org, and you just scroll down until it says take me to cool pictures, and you can go there, and we show you how to wade into the folders and grab the ones you want. But they're all free. We got like 1.5 years of stuff up there now, you know. And then
a lot of really cool stuff.
Yeah, a lot of good stuff. However, I wanted to also say we also have t-shirts, and we have a store, you know, and that's the other thing too that a lot of people are really hyped up about. Up in the upper right there, I just put it up there, you see SkyTour Shop on Etsy. SkyTour Shop, we have like 40, 50 products up there right now. You can get this guy on a variety of clothing and mouse pads and mugs and cups and everything, bathing suits, you know, socks, you know. So we actually have a lot of stuff available. Yeah, sneakers actually.
Yeah.
I have a pair of these beautiful high top sneakers that have the Horsehead Nebula on them. You know, really cool.
That would be cool to own a pair of those.
Curtis, to answer your question, which is Mark, just curious if you've tried dithering yet. I have not yet, Curtis. I haven't tried dithering, and the reason is because I haven't had the need yet. There's a couple nights where I need to do that, and let me explain what that is.
Yeah.
When you take a photograph, all right, and you take another photograph. See, we're taking multiple photographs and then stacking them on top of each other. But you get something sometimes called walking noise, where the previous photo has some noise here, the next photo has some noise a little bit to the side, on and so forth. Remember that bar I showed you at the bottom, which was a trail of the tracking?
Right.
That could leave an artifact in the view, and that's called walking noise. And so we discovered that we can actually remove all that, most of that walking noise. So I don't do what is called drizzle. I don't do what's called, as Curtis pointed out, doing the process to eliminate that, and that's called dithering. So far I found I don't have to do it. And the reason that's good for me, Curtis, is because I've got people from around the world watching live, and I'm creating the images live. I don't want to have dithering get in the way, because in between each photo, every so often, every photo, it's going to kind of move the telescope. And when it does that, then the telescope has to reacquire the object, and it has to start guiding again, right? And right now it's guiding. If you look, you'll see there's these numbers here. It'll have to take 14 seconds to guide again to catch the stars. And every 3 frames, I don't want to do that. What I miss, Mike? What are you doing down there? You behave yourself, kids. Oh, there you go.
And
There's the shoes, yeah.
Jump.
Hey, hold on. Hold that there again.
My cat
Oh, go for it.
jumped on me.
Yeah, let me just move it up there. There you go.
There you go.
That's from our Etsy shop. Okay, beautiful Horsehead Nebula images on high top sneakers. It really is cool. Thank you.
Yeah.
Those are very cool.
Yeah, we actually have about 100 products, but 50 are active up there right now. We have decks of cards. We have coasters. We have all kinds of things.
Cards.
Yeah, deck of cards. Yeah.
I would totally buy that card.
Yeah.
Can you pull those up?
Yeah, they're up there. I think they're on page 2. This is coming out beautiful. Look at that.
Was that a watch?
Oh yeah, that's an Apple Watch band. I have
Get
Apple
it
Watch bands
too.
that have our stuff on, which is really cool.
No, that's what, dude. That's really
You can get a
awesome.
clock with a moon on the face or a nebula on the face.
Wow.
Yeah. And these are
not-
all pictures we've
The
taken.
cards.
These are all pictures we've taken.
Here, let me show the cards. That is beautiful. Check out the cards.
Oh,
Check out
okay,
these
hold on, let me.
cards.
Oh yeah, they're there. Yeah, they all have the
cool.
same image on the back, but that's okay because we've got a variety of images in the back that you can get. And if people request any, I can easily have a product up there in 15 minutes. If someone says,
Right on.
well, I don't want that nebula, can we have the Flame Nebula for cards? Sure, I'll have it ready in 15 minutes. And then they could go buy it. And then they have a product that may or may not sell down the line, but who cares? It's not hurting anything.
Sports bottle. That is really.
Oh,
neat.
yeah, the sports bottle's cool.
I'm showing all your stuff, dude. We're product placement. We're all about product
Well,
placement.
no, it's cool. I think it's really cool. Very nice.
There you
Yeah.
go. And then what else we got here? What else we got?
Well, it got quite a lot, so I'm not going to show
The
everything. Oh, yeah, the socks. Look at-
Oh yeah, those are cool.
Yeah, I have a pair of those socks. I'm not going to admit it terribly, but actually I'm wearing them now. So
See?
don't say anything, because that'll make me too much of a astronomer nerd.
Oh my goodness. No, you guys have to get one of these. The tripod lamp.
Oh,
That is
yeah.
cool.
Let me put it out.
Please, dude.
Oh, yeah.
That I mean.
That's the flame.
Every-
See what that right there in that image? That's this we're doing right now. That's the Flame Nebula.
Oh.
Right.
Yeah, that's cool.
There it is.
Yeah. We also have a standing lamp too, for people that don't want to do like a desk tripod lamp. That we have a. Oh, actually, I think the other one's a desk lamp. It's like in a pewter. It's really nice. I thought, I thought these products were going to be kind of cheap and cheesy, so I didn't
No.
invest a lot of time in them initially. And then, Robin Curtis bought a bunch of samples. Marianne bought samples. I bought samples. And my family bought samples. I got some for gifts for Christmas. And let me tell you, these are good quality. Yeah.
Right?
And I picked the vendors to make them, and the vendors have to have a track record of excellence. If they don't, I don't purchase.
I'm getting a tripod lamp.
I think you'll like it.
Oh, here's the lamp on the stand. That's neat.
Oh, yeah?
That's neat. Check this out.
Oh, yeah, there it is. That's a desk lamp on the stand, yeah.
Awesome.
Yeah.
But I'm getting the tripod lamp.
Actually, I saw the tripod lamp in person. Robin Curtis bought it, and it was
Okay.
really, 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 really well made. It's really nice. Yeah,
Yeah?
I liked it a lot.
Right on. I'm so getting that lamp.
Yeah, that's neat.
The clock is really nice too.
Oh, I'm going to be getting one of those clocks. I'm not sure if I want the moon clock or the nebula clock. I mean, I'll design whatever.
Why not both?
Well, I can design like 100 different kinds.
I know there are there's a lot of designs that you can make. I mean, we're seeing them.
You have
on
no
a
idea
nightly-
how lost I became in that application when I was creating the products, because I was just trying to find a way to give back to people who want to support us. It's like, yeah, when you send in a donation of $100 to CPTV, they send you a mug. Well, that's an expensive damn mug.
Yeah, right.
Jeez. Michael Hedrick says, "Oh, you picked the vendors? I don't know. You had the power to pick the vendors." Yeah, you can. You can actually pick who you want to do these things, and you just once you know who the vendors are, you can actually select the primary vendor for the different products you have. If you leave it to chance too. I left one of my travel mugs to chance at one point, and I just got whatever, and I got one mug that's perfect. I got another mug where the paint started peeling off. That's what happened to that vendor. Out the door. Okay.
Right. Absolutely.
Meanwhile, that other mug is still perfect. So that vendor is now the primary vendor for all of our things. You got to spend money in order to see if it's really good or not. You can't just say, "Is it good?" Because they're all going to say, "Why, yes, it is." No one's going to say, "Well, not that product. We make crappy products. Don't use our products." No one says that. Unless they're disgruntled employees.
Yeah, that's very true.
Wow, this is really pretty. So you guys actually saw the Flaming Star Nebula on one of our products. Oh, did you see the blanket? It's like an 80-inch long,
Yes.
really
we're
soft
actually
fleece
planning on getting
blanket.
The shoes.
Yeah.
We plan on getting the shoes for Contact in the Desert.
I wear mine at Contact and at the other conferences. I wear them when I do my talks on stage. I wear my Horsehead Nebula sneakers.
Right on.
See, I used to have this
Where's the blanket?
trademark thing where I'd wear sneakers every time I did a talk, no matter how well I was dressed. If I was in a tux, I'd have sneakers on. And what I would do, let me show that, whatever that is.
That's the blanket. Gorgeous.
Oh, yeah. A little out of focus here, but that's okay. I mean, don't worry about it. Yeah, no, that's cool. That's 80 inches long by I think 60 inches wide. It's a big blanket.
Oh yeah, it's a little off. I put it too close.
Sorry.
That's
right.
Here's a better photo of it.
Cindy
Sorry,
Murphy, who's one of our SkyTour regulars who checks us out, she bought this blanket, and that's the Christmas tree nebula in there, okay, with a lot of detail. And I asked her how she liked her blanket, and her response was, "Well, I'm cuddled up in it now."
Right?
She goes, "I love it." So I was very happy to see that,
There's a lot of really nice stuff.
Well, that's
there.
only the tip of the iceberg. I've got so many more products that I've wanted to design, and I have to be honest with you. It's mostly because I want them.
Right?
Hey, C&D boy, how you doing? Welcome.
I wonder if you could make curtains. Dude, that would be if you had a big bay window and then curtains over it. Just a galaxy of curtains.
Actually, you know what's
Curtains
really
or
cool
whatever.
is that tripod lamp. When you turn on the
Uh-huh.
light, the room
Okay.
glows the color of the nebula. It's really pretty. Yeah. So, and that's what's nice about when you have those illuminated things, because it doesn't look like a crappy image on the lampshade, it actually is really pretty. It's very well done. I was very surprised, to be honest, because I didn't think that the printing would be good enough, but it was more than it's very good. So that vendor got stored.
Right on. Right on.
Okay, 30 shots so far of this. Let me zoom in
Hey, Fantasy.
on the Flame Nebula here. Now I want to show you Flaming Star. I mean, okay. So now, as we zoom into the middle here, all right, I'm gonna take down the noise just a little bit here. Okay, so take down the noise a little. Look at these beautiful, subtle blue reflection nebula clouds. And here's one. Look at this. You have this right here. It looks like it's more lit on this side than on that side. Okay, that's a little bit of an illusion, because what's happening there is that's hydrogen gas in there, but it's a little bit denser, so the glow is a little brighter. Okay.
Okay.
And on the other side, you have a dark nebula, and it kind of gives the impression of a three-dimensional, like hot dog shaped thing or something, but it's just a denser region, and it may go in farther and may have a different shape overall, but that's really pretty.
It is.
Yeah.
That's just, I mean, look at that. The detail.
Oh yeah.
And it's only good, you're taking more, or you're stacking longer, right?
What's that?
You're stacking this for a longer period of time, right?
Yeah, this is 33 images right now, and if we go way
Okay.
down here, it'll all but remove the noise.
Okay.
But it's okay. I like letting it decide where it wants to go.
That's right. Oh, yeah. Look at that.
Yeah, and then if I pull up on the peak a little more, it'll darken the dark spots a little bit deeper, and it deepens the saturation and the color. And then we can
Okay.
back out now. This nebula is extremely complex.
Right? It's like a maze. That is
And the longer you
lovely.
take pictures of these things, the more detail starts to look somewhat three-dimensional. It's
Right.
very interesting. Now, is that three-dimensionality real? Maybe in some cases. But it really does look incredibly convoluted, doesn't it? And that's what's neat about this. Yeah. Hey,
It
Fantasy,
really
how you
does.
doing? Fantasy's with us. What's going on, man? Fantasy was just in Death Valley. I'm glad you're back.
Yeah.
'Cause, well, Death Valley.
Back-
Well, it's not that hot out there this time of year.
Thankfully.
Yeah. Never been to Death Valley.
Yeah. It's that's north of us, right? A little bit north of us, right before maybe in between here and Mammoth, pretty much. You go,
Yeah.
you kind of go on the western edge of the Death Valley on the way up there.
Hey, Cindy Murphy just said
Yeah.
hi. Look at that.
Cindy
We were
Murphy.
just talking about you, Cindy, but I think you knew that. Is that true? We're just talking about your blanket, your blanket you bought from our store.
She saw a huge lake in the valley floor. So does that mean there was like
That was Fantasy
a
who
n-
said that.
snow? Oh, Fantasy. I'm sorry. My bad. I thought that was
A huge lake in the valley floor. Oh,
you-
that was okay. That's probably possibly from precipitation from the year or something like that. Over the cold weather, but I mean, it doesn't really get cold there. Not in the same way. It gets cold at night though.
We did have a lot of storms
Yeah.
though. Like we've had a lot of storms over the last month or
Months,
two.
yeah.
Yeah, look what Cindy says about her blanket. Oh, I love my blanket.
Right.
Is it nice and warm against the skin? It feels good against the skin, doesn't it? It feels good against its skin.
Oh no, not the lotion.
Yes. It
See,
squirts the
enjoy.
lotion in your eye. Yeah.
Oh my
Oh
god.
no.
Oh my god.
Oh, this is looking good.
Give me
I'm going to.
my.
What's that?
Oh no, I was quoting the movie.
Oh, okay.
When the
Hello,
dog drops.
Clarice. Okay, this is.
I wouldn't doubt that actually. All the mineral, like the water.
Well,
Fantasy X says, or excuse me, Michael Hendricks says, Fantasy X, so are the lakes filled with poisonous substances from the minerals washing from the rocks. That I'm not sure.
well, I mean,
Well, I
you're
wouldn't
gonna
think
get
poison.
sodium and chlorine ions for sure.
Yeah.
Because whenever you run the water over rocks like that, sodium is easily dislodged and chlorine is easily dislodged. You know, one of them needs an electron, one of them has an extra electron. So you end up finding that when they combine in water, when they all end up in water together, you get sodium chloride. You actually get salt.
Yeah.
And that is a bond that's easily broken, but it's definitely a bond that forms because the ions are loose and ready to play. Okay.
Wow.
Fantasy says it was 73 and absolutely gorgeous out there. I believe it. Fantasy, I'll be here next week in the observatory. Temperature out there will be like 195 degrees.
The oven.
Mm-hmm.
Well, it is deep desert, so you know once you leave the main road, you drive 14 miles on one lonely paved road, and then you got to drive about 10 to 14 more miles, all on dirt roads that can sometimes be washed out to get to the building. So it's a pretty safe bet it's going to be okay out there.
Good deal.
Yeah. Okay. So this is good. I'm going to save it here at 47. All right. We don't necessarily have to go to 50 for this, but I think it's really pretty. All right. This is now being saved. So everything we just took pictures of, the horse head, the flame, this is now up at the server at skytourlive.org. You can go up, scroll down to find cool pictures, and wham, you can actually see this and download it just like this. In fact, what you get, if I click on that, this is what you actually get. This is what is not that. You get this image. That's the whole picture right there. Okay, so that's up there for you to download. Yep.
Wow.
Yeah. Neato. Okay.
That is just,
Very pretty.
yeah. Right?
Yeah, it is, you know.
There's just so many. There's just so many stars to look at. It's. I don't
Well,
know, man.
mess with your head even more by saying to yourself, those could all be other suns, effectively.
Right.
And they could have
Right.
worlds
That's
around them
right.
with life around them. And at this point, we don't have any idea how many are out there. But, I mean, for those that know about the book I wrote called The Populated Universe, I make the argument in that book that life in the universe is the rule, not the exception. And then I proceed to give a scientific set of reasons why that's true. So that's available on, if anyone wants it, it's on Amazon. It's a big, oversized book, and it's got color imagery that much of which I did myself, not here, but in another product. I generated imagery for the book. Some of the pictures are ours from here, but that kind of thing. Spider and fly are close, Ray. He's asking for those, but we're actually leaning way over a little bit too far. Spider and fly are up here. They're a little bit farther, to the east, so they're going to be a little bit higher. But let me go, before I do that, if we do that, I just want to look elsewhere for a moment. Yeah, see, we got a lot going on here. Let us go to the other side, cross the North Pole, and let's go see what's over here and what's coming up over here. All right. So we have a little bit of time. We have some galaxies in Leo that we might be able to check out. Let me see what our...
That would be
yeah, we'll
amazing.
get some galaxies tonight. Why not? So let's go into the constellation of Leo the Lion, which is right here.
Oh, right.
Leo.
Yeah.
That would be I.
God.
That's you? Oh,
Yes.
well,
I was the sign of the Leo, king of my jungle.
okay.
No, not quite. The lioness says no.
All right.
And we all know who really runs the jungle,
Uh-huh.
right? The lion.
The lion.
Yeah.
Nah. So let's zoom in a little more here until our galaxies show up. Yeah. All right. There we go. We got some galaxies showing up here. All right. Let's check out the Leo triplet. I think we should be able to see the Leo triplet. It's 44 degrees up, and we should be good. I'm also going to do a focus run. Watch, the telescope's going to swing all the way to the other side here. Okay, so let's do that. All right, and come back here. So this is just about the border.
James.
James?
James Height.
James Hyatt. Oh, there he is.
Yeah.
Hey,
Good
James.
evening.
Nice to see you, James Hyatt. James is one of our amazing Patreon contributors. Thank you, James. As is Tiffany.
That
one right there. Okay, let's...
A cat in her arms. Who is this?
That's not-
Shadow.
You have a cat named
Yeah.
Snuffleupagus?
She calls this
I
cat,
call her Muff.
and
Oh.
I call her. Her original name is Shadow.
All right.
That's Tiffany's muffin, because she likes to
She's
make
my
biscuits.
best.
Oh, okay.
Yeah.
As long as they're not air biscuits.
Right.
Okay. Let's move a little bit to the east here. I want to make sure that we capture the galaxies. All right, let me go back to here. I also have to
Oh, Garbage the cat. Where's Garbage?
oh yes, you have a cat named Garbage.
She's bathing
She's
herself.
bathing.
Well,
Yeah.
that's not right. She's supposed to be a stinky cat. That's why she's called Garbage.
Right. That's what I said.
Yeah.
They're just.
I'm going to go up to this star right now because I want to synchronize the telescope here. That's the star. I believe it's that guy. I will know in a minute. Let's see. Okay, bringing up the planetarium here. Oh, come on. Come back.
Wow, 35 million light years away.
Yeah. let's go in here.
Thanks, Cosmic. That's incredible. That's incredible.
All right. Well, let's do this. This is our view. So, all right. I have to wait for Starlink, Mike.
Oh no. Well, while we're waiting for my company to, Michael Hendricks says, Mark, are there observatory locations in Peru?
Not ours, but in Chile, there's quite a few of them actually. Paranal is where a lot of those are. It's really quite the site and location. But you know, it's up on top of a mountain, so every day of the year it's freezing up there. So I'm okay with not going there for more than a visit. I'd love to go and check it out. All right, there's Regulus. I wasn't sure how much time we're going to get tonight with the telescope because we did have some clouds coming through, and right about now is when they might actually be getting in the way. So let me find out. But first of all, let's do this. Let's center up Regulus in here, and once we center it up, we will then use that. All right. Man, it's taking a while. Okay. All right, I'm just gonna restart this right now, so you'll see it disappear for a moment, and then I'm gonna start it back up. There we go. And obviously, I gotta readjust a few things. Let's readjust a few things. There we go. And let's do that again this way. I gotta do that. I think that's good. Okay. Now I will pull this down again. Okay. All right. And that's good. And now we go into our planetarium. And you'll see that when we look at Regulus, which is the brightest star in Leo, the telescope was off a little bit. So what I've done now is I'm going to now synchronize it, and you'll see that crosshair center over Regulus. There. So now we're good. So now wherever I go, we are going to be guaranteed to be right in the correct ballpark. And before we do that, what I'm going to do is come back here, shut off this guy, the reticles. We don't need reticles. Okay. And let's turn off the reticle. And once we turn off the reticle, we'll do a focus process. I don't know what's going on with our Starlink there, Mike.
Yeah,
Oh,
I know.
my God.
I gotta get up there to Washington and whip those boys into
Yeah,
shape.
do something.
What's the deal?
Yeah. All right.
What's the hold up? That's what they like to say. What's the hold up?
Garbage.
Well, we are actually going to be launching a lot of more
Oh, you guys
satellites.
were- This garbage
this year.
first.
There we go.
A lot
we're gonna
more
do
so.
this. And then we're going to go negative and let it focus.
I actually had a question. Cosmic Ray says that there's 3 galaxies in the M66 group that have all been affected by their gravitational interactions with each other. Will they eventually collide in some way? Or are they just too distant, too far apart?
No, not necessarily. It's possible they could collide eventually.
Okay.
And the Whirlpool Galaxy is a perfect example of a galaxy that had exactly that happen to it. It was a beautiful galaxy, and its spiral arms are in part due to the interaction with the other galaxy that collided with it. And if you look at the Whirlpool Galaxy from here, when you look at the Whirlpool, it has this little satellite galaxy here and like a little tail, right? And that tail has a wisp hanging off it, which goes to the main galaxy. Look at it from the side, and it's going to look like this. Okay, this galaxy went through the Whirlpool and dragged and warped the disk of the Whirlpool. And we know that from studies of radial velocity. That is the velocity of motion to and away, toward us and away from us.
Right. That's cool.
Here is our...
That's a stunning sight.
This is our parabola being made here, and we'll see a center line show up here in a bit. There it is. And that's the line of perfect focus. It's a calculated position. It's not necessarily the exact spot where it moved to. So that looks like it's pretty good. So we can say best focus now. And so the focus position is going to swing all the way over. So it's going to go back out of focus and then come back into perfect focus. And that is right there. The stars are the smallest. That's what it's doing. It's actually measuring the diameter of the stars and making them the smallest they can be. So now what we'll do is go here, zoom out a little bit, and take us back to the Leo triplet so you can see these galaxies. I have not seen them with this camera. I'm really looking forward to it. I'm actually going to go to this location. I'm not going to go to an object.
You see that moving?
What are you talking about?
Oh.
On the left middle of the screen, there's like a little slice of something moving across the screen.
Oh, I see it. That's a satellite.
Okay, that's very cool.
Yep. You see it. It's right there. It's heading out of the view.
That is really cool.
Okay. All right, let's come over here to the Leo triplet. Come on. You can do it.
That was literally that was really cool looking, to be honest. It took me away for a second.
Well, there's so many of them out there, you know?
Yeah. Oh yeah.
Oh, okay. Once again. All right. Jeez. There we go. Come on. All right. So there we are. We're going to have the Hamburger Galaxy and then the other two from the Leo triplet. And now I'm going to tell the telescope to go just to that space in the middle there. And the Hamburger should be at the top and these two should be at the bottom. So here we go.
Wow.
Now that we're aligned, we should see that. Okay, there's the two. And there's the Hamburger. All right, so what I'll do now is, as we get our telescope control back here, it's doing the final positioning. There we go. And then I'm going to move us up a little bit just to get us in a best position. Yes, if I could have a hamburger today, I'll gladly pay you Tuesday. We'll call it the Wimpy Galaxy.
The Wimpy Galaxy.
Donald Kunzer is not going away for the night. He's back. Okay, here we go.
Oh, Curtis, why would you say that?
In and out. Wimpy Galaxy, yeah. Okay.
Michael Hedrick might have a question for you in a moment.
Okay. All right. Okay, we are guiding now. And Michael's always nice. He asks, can I ask a question? You don't have to ask. You just go right ahead and ask Mike. It's okay. And what you do is you put them all in caps because that's what I require. Not require, but it makes it easier to see. But Michael Hendricks asks, do you think there's a limit to new technology for how much resolution we can get when looking for exoplanets? There is a practical limit based on the atmosphere, and that sets limitations on us. The best thing to look for exoplanets with is a satellite that can actually do a direct, unbiased view of the sky and the stars. And that's something that the Kepler Space Telescope did. And when the Kepler lost one of its control wheels, reaction wheels are called, they were able to use the solar wind striking the satellite, and then they recalibrated the other reaction wheels, and so they actually stretched out Kepler from when it should have failed to a point where it actually became way useful again, and that was the K2 part of the Kepler project. Then we had TESS, Transiting Exoplanet Survey Satellite. Yeah, look at that, 3 galaxies in one shot. And these are all very likely near each other in space. Their distances will be similar. Okay. And like for instance, see this galaxy, it's a spiral, right? Now how do we know how fast it's rotating? Well, again, we can look at the radial velocity, the speed of the stars coming at us, okay, versus the speed of the stars going away from us on the other side, and figure that out. That's actually a very important element of something called the Tully-Fisher relation, which allows us to decide some and see some really interesting parameters of galaxies, especially those that are far away. So we'll let this go. This is the first time I've ever seen the Leo triplet with this camera, and it's astonishing. I'm going to actually drag this right to the top.
I'm like at a loss for words with this. These are 3 galaxies, people. These are 3 galaxies in one shot.
Yeah.
I'm at a total loss for words here.
Are you blown away?
I'm blown away.
Look at this. You can see it looks like a dinner plate on its side,
Mm-hmm.
That is really pretty. Yeah.
It's not even the distances. It's just you can't. I don't think anybody can comprehend whatsoever.
Michael also asked, "What is the astro community's priority with astronomical exploration?" Well, it has a number of mixed priorities. Okay, all good. In one case, we're looking at galaxies like these and trying to figure out more parameters of the galaxies that have eluded us for a long time. In other cases, the priority is trying to increase the capability to detect atmospheres of exoplanets. That's huge.
Right.
That's huge. Don't forget, James Webb Space Telescope managed to pick up what's called a Hycean world. It's a world that has a hydrogen atmosphere, yet it seems like, based on the other spectral information, that we're actually looking at a water world. Now, to be fair, our Earth might look like a water world from some distance, so there's not saying there's no land there. There might be. Okay, but from a certain perspective in the Pacific, You look at the Earth and all you see is water, no land. And that's because the Pacific takes up the largest amount of surface area of any of the oceans. So when you look at a water world, and especially one that's a Hycean world, meaning it has a hydrogen atmosphere, the first thing you think is there's no possible life there. And you'd be right if you're just considering human life, okay? There wouldn't be human life there. Human life there is not something that would actually be, that would actually work. Because obviously it's not conducive to human life there, okay? So what would they do? Well, let's see. They would actually end up having a potential for a different type of life. However, one of the things that's really important is that the potential life that's there is a little strange, because this particular world showed a signature of an elemental compound that was actually rather complicated. It's called dimethyl sulfide. Now, what's that and who cares? Well, the reason you care is because on this world, light years away, we discovered a compound in its spectrum that is only created by life here on Earth. Dimethyl sulfide is literally, effectively, plankton farts. Okay? That's the smell of the sea. When you go at low tide, you go, oh, what's that stink? The mud, you think, smells so bad. It's the smell of the sea. That's dimethyl sulfide you're smelling. And that dimethyl sulfide, as far as we know, is only created by life. So what does it mean when the James Webb Space Telescope detects dimethyl sulfide in an atmosphere light years away? If the finding is corroborated and confirmed, it means that the James Webb Telescope probably found life on another world. And it's life very different from life here, because it would be life that is on a Hycean or hydrogen-based atmosphere world, and that is the new thing that we've never seen before. So that's pretty cool. Hycean worlds, new, interesting, very exciting. Don't take them home to meet your mother, because you can't breathe hydrogen. You know? All right, let's do a color correction here. Get our black space. There we go. Look at that. Look at the detail in this galaxy. We should be able to zoom in on this now. Look at that detail. Wow. That is way more detailed than we've ever seen, because we're using a camera that, as I said, is very well tuned to this particular telescope. Let's get a little more detail. Look at that. Very complex. Now you see the convolutions. This spiral has this weird shape going across it like that, right? Why is that? Well, it could be because it had some type of interaction with that galaxy there or this galaxy here. This galaxy has like fuzziness at the end, more on this side than on this side. So that implies that this galaxy has interacted potentially with this galaxy or both. You know? And interaction doesn't mean it passes through it. It can just mean that they're close enough to kind of drag material off each other with their massive gravity that they have as galaxies.
That works in that's so odd.
Yeah, look at that though, huh?
Right?
Now, if you were in this galaxy, all right, which is actually highly detailed, and you looked out into the universe, you'd see a galaxy that was a huge angular size in your sky. Because these galaxies are near each other in space. How near? Well, let's go back to our guy here, this guy, and let me go down to... Oh, that's not where I wanted to be. I wanted to be at the thing here, but I forgot I didn't have a specific selection. So now we'll go back to the Leo triplet here. There we are. And we're not there yet. We'll get there. Just a minute. Let me back out here and get us there.
That is so amazing.
Well,
That is ridiculous.
we're approaching galaxy season here, as you'll hear Daryl say on some of our streams. So we will see incredible numbers of galaxies, okay? But let's go now and let's take a look at these two, okay? This is one of the Leo triplets, right? Let's center that up.
Okay.
And
Michael has.
yeah, okay. And let's see, does it give a distance to this guy? It doesn't give us a distance as far as it gives a redshift, we could convert to a distance. How about this one? All right, this one, it says it's about 35 million light years away. So you're seeing it about halfway from the Jurassic extinction to here. Yeah, okay, that kind of thing. And let's go back to this. Let me see if I missed something. No, it's probably a similar distance, okay? And then let's look at the Hamburger Galaxy. Yeah. In Japanese, hamburger is hambaga. Hambaga. Yeah, it's called a loan word. Loan. All right, so there's the Hamburger Galaxy, and it's 45 million light years. So you can see that it's slightly further away from these guys, but it's probably doing this. It's probably orbiting and then coming back. We're seeing snapshots in time here. You know. So yeah, that's really cool.
Millions of years ago.
They are billions of light years away. Carl Sagan was my favorite astronomer.
Oh, absolutely. I remember Cosmos, watching Cosmos as a kid, man. So amazing.
Look at the detail in this dark lane of dust here in this galaxy. This was unavailable to us with the other camera. So this is really something. Oh, man. I'm going to have fun this galaxy season, I can tell you that.
I can't wait. I really can't wait.
We're already kind of in it now, aren't we?
Right? This is spectacular. Are you kidding me?
This is beautiful. I hope you folks are liking this.
Oh, I'm sorry, Mark.
No, I said I hope you folks are liking this. Speaking to everybody here watching. Now, Michael Hedrick had a question.
Yes.
Okay, can you read me his question, please?
Absolutely. He says, Mark, do we know how many galaxy widths apart they have to be? How close they have to get at this mass to interact?
Well, here's the truth there, Mike. When you have a galaxy cluster like this, like in the Leo group and the Virgo cluster, you have nothing between the galaxies effectively. That's not necessarily exactly true, but for the argument that we're making, it is. And so all you have is the gravitational tugging that is affecting you from other galaxies nearby. Even though the Andromeda Galaxy is 2.4 or so million light years away from us, the Milky Way still feels a galactic gravitational force from that galaxy. So it's still tugging on us a little bit. And technically, if you want to really be, proper, every galaxy we see in the sky could effectively be tugging on us. It's just a matter of to how much extent there is that's doing it. And it doesn't necessarily have to be a large amount. So in other words, it depends on the mass, like you suggested, Michael. And it depends on the proximity, as you suggested. The closer you are, the more pronounced the effect. Okay? Now, gravity falls off in terms of its strength by the square of the distance. So if you go 4 times further away from an object from its gravity, the gravity is 16 times less effective. Twice as far, 4 times less effective. So obviously, when you get millions of light years apart, or just a few tens of thousands of light years apart, even, Tens of millions of light years apart, then that amount will drop significantly. But because the overall mass of the galaxy is still pretty high from the very beginning, you can get some real effects, right? Like this warp and this spiral arm. That came from somewhere. Now, we don't know if that's a spiral arm that's sticking up like this off the galaxy. Okay, it might be. And it's just in front of us, so we can't really tell. But it's probably, this could be dragged up into space against this flat plane of this galaxy. We don't know. And that could have been caused by this galaxy. Or up there, the Hamburglar galaxy. So, it's all quite possible. I'm going to save this at 32.
That is so.
And Michael asks, and this is actually the best question of the night, actually, Michael. From you, I should say.
Okay.
Not you, Michael, but Michael Hedrick.
Okay.
Wild idea question. Can we determine the shape of another galaxy by the type of tug it gives us? No, but that tugging that galaxies exert on each other are responsible, we think, for certain things like the shape of the spiral arms, the actual existence of spiral arms. The Whirlpool Galaxy, it looks like, through interactions with that satellite galaxy that tugged some of its mass down, actually also created the spiral arms in the galaxy. There's a number of theories about how spiral arms form. One of them has to do with what's called density wave theory. I call it traffic jam theory. Now, the stars go around the galaxy. Okay, the stars in this galaxy are going around the galaxy. But there's spiral arms in there, so you think, well, maybe the stars are confined to be in those spiral arms. Well, that would be nice, but no, that's not how it is, unfortunately. The stars are cruising through the spiral arms, and they keep on going. They're slowed down a little bit by the knot and congestion of other stars in there with their own gravity, slowing it down a little bit, but then they get out of it and continue on their way around the galaxy. So how is it that we see spiral arms? Because it's in those regions where the stars start to get a little bit of clumping, all right, and that you'll see other stars form, and that forms a local gravitational tugging, as you were saying before. And that local gravitational tugging will prevent some of the stars from passing through at the speed they may normally pass through at. So they may temporarily slow down and then speed up later as they're being tugged along by other stuff. And that overall view is that there'll be a spiral arm in that location. But that's why the stars aren't always the same in the spiral arms. Now, we have to look at scales of millions of years, tens of millions of years, to actually see that this is true. So it's a thought process, and probably a very likely process. So if you're in a traffic helicopter and you're looking down on the highway and you see a traffic jam on the highway, you know from being in a traffic jam that you come up on the traffic jam, you slow down, and then eventually you pull out of it. But if you look at the highway from the air, you still have a traffic jam. And let's say you see a red car coming up. You see a red car come in, it slows down, and then it makes its way through the traffic jam and then finally speeds up again, right? But the traffic jam is still there. All the cars are coming into and exiting this knot of traffic. And every so often, the population of the cars in that knot of traffic jam totally changes 100%. Okay? That is the concept of a spiral arm. That's the concept of density wave theory. The traffic jam is a density wave. A wave of density moving through a particular path. And that's what we think spiral arms are. And their nature is, of course, dragged out over millions of years, right? And they get dragged out a little bit because there is some differential rotation, meaning the stuff in the center moves a little bit faster than the stuff along the outside. So if you have a knot of stars forming, they will get draped back as the rotation is a little bit slower on the outside for them to go around the center a little bit faster. So the leading edge will always get dragged around the nucleus of the galaxy quicker than the outer arms, but not enough to account for what we observe. And this is in part where dark matter comes from. We think there's a halo of this strange exotic matter we have yet to be able to fully identify that actually assists the galaxy in rotating more like a solid disk than a true galaxy with these spiral arms. If you think about it, the universe has been here for 13.8 billion years, we think. Okay, that may be changing. But in that time, that set of galaxies out there that have spiral arms, because of what should be the proper differential rotation, there shouldn't be any spiral galaxies. They should all have wound up, and they haven't. So what could cause the galaxies to not wind up? Well, something that prevents the outer or the inner regions and the outer regions from having very different velocities as they rotate. And the only thing that could be there is mass we don't yet see. And that's what dark matter is, and that's why it's called dark, because we can't see it. It's not because it's black. All right.
The more he stacks, the more it just comes in.
Yeah.
It's just,
Yeah, let's zoom in here.
Stop it.
Yeah, look at this galaxy now. Look at all this detail in here. That is just beautiful. Just wait until we remove the noise here and make this beautiful noise-free image. You know, you guys get this noise-free, this noise one here. That's free. But if you want to get the noise-free images, that's for the Patreon subscribers who join us. You know, we have to do something, guys, because we want to be able to keep providing this to you, and so we have to have some support. Our internet costs hundreds of dollars a month, because Starlink, you know, is not cheap.
He's giving them money every month.
Yeah.
Right. Thanks, Mark, for supporting Starlink. Paying my paychecks.
Oh my
Well,
God.
But it's the circle of
The
life,
Patreon. Yes, because life depends on satellites. The thing is, okay, we also have to thank our Patreon subscribers, because they're the ones that are supporting the internet payments for us right now. Okay, and
Right.
obviously we want to get our solar facility in here on the East Coast. We want to put the second one in out there, and we still have to dig into our pockets, because you know the donations we get are fantastic, but it doesn't cover the building that has to go up, or the enclosure that has to go up. It doesn't cover the cost of the linear actuators to move these beautiful pedals from this building to push these off. That's the cheapest route to go, and it has to withstand winds of up to 80 miles an hour. So out here in the desert, we have winds of 80 miles an hour sometimes, and this particular design manages that quite well. Yeah.
Now, Sam S., you're not far from the truth there. Sam S. says Starlink should sponsor the stream. I mean, that's essentially what we're trying to do as a team, Tiffany and I. We are trying to get you guys like Celestron telescopes, Celestron binoculars. There will also be in the future. There'll be psionics. Oh my gosh, night vision binocular. So in essence, this is kind of like a full circle thing, where the Patreons definitely help out the stream, help Mark D'Antonio, pay for the bills, and then in turn, he keeps me employed, right? So as long as there's Starlink, as long as I have a job at Starlink, I will continue to purchase Celestron telescopes and offer them to you guys, those who support the stream. I mean, this is why we ask you guys to like, share, subscribe. Definitely, even the comments. You guys asking all these questions. Yeah,
great questions.
Having these conversations. This helps the algorithm reach other people. You have no idea. Like even the smallest of questions, anything, even the conversations that you guys have between one another, that helps greatly. It helps a lot.
Yeah, it does.
So thank you guys very much. I mean, we can't thank you enough for joining us on these streams, because it helps a lot, and we want to be able to bring you more of this content, and we're doing our best. Mark does a fantastic job at bringing Daryl, the entire team. This is why we chose Mark as the exclusive, nonprofit to offer these skywatching.
Well,
this
yeah, and
skywatching
that's actually wonderful, because there's no question that we're passionate about this. That's, I think, pretty darn obvious, right? Gotta just be on top of this all the time. I want to start streaming the solar stuff too. My gosh, I have a feeling that, like I said, I guess I'm not going to be sleeping much. I won't get to sleep during the day. I won't get to sleep at night, because we're going to have 2 telescopes running at night in Arizona. In fact, right now, once in a while we get clouds here. And, in Arizona. Okay, I'm in Connecticut, running this from Connecticut, which is why we have delays sometimes. But that said, even though that we get clouds in some areas, we're going to another part of Arizona, and next week when I get out there, we're going to go to another part down in southeastern Arizona, where if it's cloudy in western Arizona, southeastern Arizona may very well be clear. It's another magical spot that we found, and that telescope will be running at the full f8. It's not going to be an f2 system. It's going to actually, for instance, the galaxies we were just looking at, those galaxies would be nearly filling the field a little bit more. So we'll be looking like a laser at objects. And the thing is, we'll be doing it at the same time. So you'll see a view like this with the view we just saw, and then we'll switch over to the other telescope, and you'll see what it's looking at right then and there, and see the amazing difference and how much more detail we'll see there. It's really going to be a wonderful experience. I just can't wait. So we're going to have a lot of fun with that.
Honestly, I feel I want to run like this content. If we can get 20,000 subscribers by October,
oh, we'd love that.
I'll personally run a contest for a psionics, and I'll pay for the entire thing.
Well, that
by October, by Halloween. If you guys can help us get 20,000 subscribers, 20,000 subscribers by October, I will personally purchase for a contest a psionics night vision monocular.
That's the one.
Yeah, you guys have my word. There
fantastic.
You go. It's done. It's done already. It's now all over the internet.
That's it. Keith Evans, thank you, man. Do you see what Keith Evans did?
20,000 subscribers by October 31st. There we go. By Halloween.
Keith Evans actually donated $20. Thank you, brother. That is so nice. Thank you so much.
Thank you. Thank you very, very much.
I just saw it come in. I was like, holy cow, that's amazing. I'm very, very happy that this stuff means something to you guys. All right, let's move over now. We're going to be seeing a couple other nice galaxies. This is not the Leo triplet. This is a different location. Let's go see what these are.
Django, good morning, brother. Oh, I'm excited. Yeah, we're doing this. We're doing.
Yeah, this. Ronald is a tremendous supporter of SkyTour livestream. There's so much stuff we can't do without guys like Ronald. Let me tell you.
That's right.
Yeah. Yeah, absolutely.
You'll ace 20,000. Right on.
I'd love it.
We hope so.
I'd love it. Everybody that's listening is just great.
We're going to, looks like NGC 3384.
Yeah.
Am I reading that?
Yep. There we are. Okay. Cosmic Ray, always full of wonderful thoughts. 8.2K subscribers is a pittance. Well, I mean, compared to PewDiePie, yeah, absolutely. Yeah, okay, so we're here.
Beetlejuice will go off and we'll hit millions. That would be amazing if we can actually be homing in on Beetlejuice as a.
Yeah, and if Beetlejuice was a star, that'd be even better.
Right?
Oh, you mean Beetlejuice? Okay.
Beetlejuice. Okay.
I'm kidding with you.
Can't say Beetlejuice.
Yeah, I know, because then Michael Keaton will actually go, "It's showtime," So we don't want that. Right. Okay, so we're gonna do a 25-second shot of this field with this galaxy, and this galaxy, these other galaxies that are in here. One of the things you'll find is that even though we're taking pictures of a particular set of galaxies, you'll also find that there's many more other galaxies in the field as well. And let's take a look at this view. Okay, not this view. This is the old one we just took. And let's see what we can see for galaxies in this view. Mr. Django's with us from Belgium. How you doing, man?
Yes, sir. Mr. Django, good to see you, brother.
Yeah.
One moment, Mark. I'll be right back.
After these commercial words. Tiffany, what the heck you laughing at? She's laughing up a storm over there.
I
yes.
am.
That's okay. We're going to back out here just before these come into view. I want to go to the full frame. Okay, there's the full frame roughly. All right, we're at 22%. We're going to color correct, which won't really do much. And then I'm going to do this to start pulling out faint detail. All right. So there's a galaxy there. There's a galaxy there. There's a galaxy there. And there's a galaxy right there. Well, heck, I'll just show these to you, okay? The galaxy over here is inside this box right there, okay? And we have these three, all right? And the more you stare at the screen, the more galaxies you'll see.
What?
Inside the box, there's a little tiny galaxy in there. And then we have these three. And we might find more in here. Now, if you think about it, what if there's civilizations in this galaxy out here? They're hopelessly lost to us. We'll never, ever know. Even with the best technology we have, unless they can get a signal to us via some type of methodology faster than light,
Do you think there is sciences that we are unaware of?
Oh, absolutely. Yeah, very, very clearly is true. Yeah.
Mm-hmm.
Let's just back out one more bit here. I'm looking for besides that guy. There might be more in here, but we'll certainly see more in a little bit here. First, let's zoom back into our targets. All right. This galaxy is the one in particular I was interested in because it actually has this really strange look to it. But let's bring our black level up so we can get a better contrast with the background.
Cosmic, it's not really about having two more observatories to increase more subscribers. It's actually bringing it to you guys who already watch the stream on a regular basis. And we're bringing you new content for you guys. You know what I mean?
The reason for the different observatories has to do with what we want to get out of this. What we'd like to do is show people the wide field view, show people just this, or just this or this. And then we want to show people the sun. So we want to cover various aspects of astronomy. Deep sky,
Absolutely.
deep sky astronomy, wide field astronomy, and solar astronomy. Now, here's another thing. Keep in mind, the telescope we're putting in out there is going to have a filter wheel on it. That filter wheel is going to have narrow band filters in it. And we're going to take the narrow band filters, and that'll afford us the ability to put things in the Hubble palette if people want to see the Hubble palette and the regular palette, unless the colors. So it's going to afford us a lot of detail we might otherwise miss. Now, right now, we're using a generic, it's really far from generic at $1,500 for the filter, but it was $1,500 for the filter we're using right now to show you this image. And yeah,
Oh,
I
wow.
know, but you know what? Worth every penny. Okay.
That's right.
Yeah.
It is.
Yeah.
We bought two of them because one goes in the telescope going in out there, and one is in this telescope here. Now, because this has a lens, the camera's on the front, we can't put a big filter wheel on the front to go through filters because that's this big around and it'll block a ton of our view. So we have just one filter in there, and we chose this particular filter. I have another one called a radian filter, which is also $1,500, and that's here. And that was going to go in this telescope here, but I'm going solar at this side of the country.
Okay.
So that is no longer going to be a viable filter.
Okay.
Yeah, look at that.
That's extraordinary.
So these galaxies here are really interesting because you can see subtle detail in these.
Okay.
All right.
Oh yeah,
the
definitely the
bottom
bottom
one.
one. We're currently watching this on you see us moving our heads towards the, I guess your left, right? Okay. Anyways,
You're looking at the
we're
big
looking
screen,
over-
that's
look-
why.
We have a 60-inch screen here, and it's just incredible.
Here, let's make it even more incredible.
Oh yeah, please. I'm on it. I'm all over.
All right, here we go. Let's do this, and let's actually just go past the peak just a little bit, darken up that background, and then soften.
Oh, look at that! Look at that!
Now we'll
Oh man, look at
now we'll
that!
soften this a little more. Okay, now you can see some more detail in here that you didn't see before. Now these three galaxies probably interacted, but I do want to check the distance on that one. That one might be further away,
Okay.
and that's going to be NGC 3399, I think, or 3389. And that's a distance of 80 million light years. Okay, and this one's a lot closer, if I recall. Let's go see. Yeah, it's 26 million light years, and this one's going to be about a similar distance. This one is 31 million. So this is a lot further away. So these two galaxies very likely interacted with each other and have been. This one is a lot further away, so it's probably out of the range to interact. Yeah. And if we go back to this guy, this one is it's a galaxy, and it's not sure whether it's a spiral or just an irregular or a dwarf galaxy. I'm not sure. Actually, we can certainly look that up. It's NGC 3389. So it looks like it's the type of the galaxy is given as a number, and I'm trying to remember what those were. That means it's probably a peculiar galaxy of some kind. Interesting.
I'm floored. Absolutely.
You're not the
floored.
only one. So, okay, this will
Wow.
be the M105 region here. Again, never taken pictures with this camera. This is all new. Really cool. K105 Galaxy. We'll get to 20 and we'll take a shot and store that.
I have a question, Mark. What,
I have an exclamation point.
You might have already mentioned it, but I might have missed it. The brightest blue star on the right, upper right corner there. What is that?
Oh, you're talking about back in this image?
Yes.
Now let me jump into the live stack again. It's not deleted. It'll be back.
Okay.
That star?
Yes.
Okay, well, if we go into our planetarium view, this square is our field of view. So
Okay.
you're talking about this star right here, and this star is a let's see, it's a spectral type. It's an A2. So Vega in the summer sky is an A0, and it's like a white star. So this one is a white star. Okay. In other words, it goes from blue to white, and it'll have a fringe around it that is sort of affected by the background. So it's not necessarily gonna show exactly as its color. The orange stars, the K-type stars, do. Like these two up here. This one looks like it might be some type of a K star. Let's go see. So up above, we are gonna have two stars, which is this them? Oh, it's a G. Okay, that's a G5. So that's kind of a star, a little slightly later in type than our sun. Ours is a G2. But that's pretty cool. And down here we have Measure 96, which is also interesting. But I'm going to go look at Measure 95 with you now. So
Okay.
we'll just select that, and I'll save this one more time. Oh, I can't because I already stopped it, didn't I? Duh. Okay.
Oh, Measure 95.
Wait a
Ooh.
minute. Hold on a minute. Yeah. Okay. This is good. All right. All right. So this is good for these guys. So now let's go out of here and let's go look at a bigger galaxy now.
That was a fantastic
Ian
shot.
Kendall's with us. Hey, Ian, how you doing? Yeah, it's a 183 MC by ZWO. One shot color. Okay, and let's bring this up. This is crazy, because it's weird for all you listening. I spent a year trying to get all this stuff to work together, and I did it with a test bed out here. We had a real dome on the front lawn. And it was the talk of the town because people would drive by and take pictures. Look at that dome, Ethel. I think it's a missile silo. Yeah, yeah, we got that too. I was like, no, here, I'll show you what's in it. I don't want to go in. There's a radiation. No.
Oh, no. It's an Integratron. Like they have
Yeah, that's right. Yeah, no. Yeah. So let's now go to do this now. But when they walked in there, they saw a telescope like this in there. Actually, that telescope's behind me. The telescope that was in there is behind me here in my office.
Yeah.
And so we're going to go to M95 now. This one is really a phenomenal galaxy. It's actually called a Bard Spiral. Yeah, Bard, not Board. Bard.
Bard?
B-A-R-R-E-D.
Borg.
Not Borg.
I'm kidding. I'm kidding.
I am Locutus of Borg. You will be assimilated.
I think we already
It
have
is
it.
inevitable.
Yeah.
Yeah.
Okay.
Beautiful.
Not yet, it's not.
Absolutely. That last image of the three, where it was just.
See, we're only doing
It makes you really feel insignificant. I'm not even kidding.
Well,
Like that.
it
It's just,
does. It makes us realize how small we are.
right.
You know. All right, 25,000
And
milliseconds. Resistance
There's
is
gotta be-
futile. Ian Kendall said that.
Oh, it did.
Okay. All right, so I think we're good now. We got our guide star, but I'm actually going to move us slightly to the west. I just want to center it up a little better. Doesn't have to be, but I would like to make it a little more central.
Yeah.
Okay. Sorry, folks, we're waiting for Michael.
What'd I do? What'd I do?
Your Starlink, bro.
Oh God.
It's
no,
not
you
broken. It's not broken at all. Just now and then, it's again, maybe there's something you can explain to me, Michael. There are some sites that are kind of low bandwidth and high bandwidth sites for Starlink.
Yeah.
I think we're in a low bandwidth site in western Arizona in the Sonoran Desert. Is that permanent, or will I end up getting better service at some point?
You'll end up getting better service as we launch more Starlinks into space.
To cause more problems with our views. Yes.
Yeah, pretty much.
Well,
There'll be a
I had
line
to ask.
through everything that you take photos.
You know
of.
what?
It'll just be a
When
massive
I
line.
used to take pictures of the Orion Nebula, I never had as many satellites as I do now. But guess what? None of
Yeah.
them are Starlink. They're all the geosynchronous satellites. That's why they make horizontal lines moving through. So if you take a 25-second photo, oh, this is gonna be pretty. This is gonna look like a steering wheel to everybody. As you take a picture of the Orion Nebula, that's almost on the celestial equator, and the geosynchronous satellites ring the celestial equator. So you always see satellites now in Orion. You never can take a picture without them because they're between us and the Orion Nebula out there. Yeah.
That is kind
So it's kind of unfortunate day.
of, yeah.
But that's all right. I live with it.
Well, it's just not my fault.
What?
What?
No, this
Just
isn't
saying.
your fault. This one time isn't your fault.
Just one time. Hey, Judy, I'm good to see you.
Hey, Judy. Hi.
This one is just.
Yeah, she's like being super lovey-dovey today. Oh, Shadow Baby. Where's my Shadow Baby?
Shadow's the name of a bald eagle out at Big Bear.
Oh, that's right.
Oh,
That's
yeah.
you know, I've been watching that. You got me hooked.
Shadow and Jackie.
I'm hooked. Yeah, I'm absolutely hooked. I watched her throughout that entire storm,
Yep.
and I watched her all the way until that storm cleared.
Yep.
And it's beautiful, absolutely beautiful.
Yeah, it's really, really pretty. I liked watching. They roll the eggs, to keep the yolk sacs and everything from sticking to the side of the shell. So they
Right.
roll the eggs so that won't happen. So the chick won't, get stuck to the shell, which could be a death sentence. So right now, they, as far as I know, they don't think the first egg. There's 3, which is kind of rare for eagles.
Right.
The first one may not be viable because they're passed by like 5-10 days.
That's right. They were supposed to hatch
Yeah.
a while ago.
And
They were. That's what I.
and
read
the other
anyway.
2 may also not be viable. We don't know. The thing is, bald eagles, they're pretty much they'll do anything. They'll get garbage. They'll get live fish. They'll snatch live fish. They'll eat garbage. They just eat whatever doesn't move, and what does move, they're hunters. They grab fish easily.
Yeah.
You know.
That's not.
Yep.
Not. Oh man, that sucks.
Yeah, but we'll see what happens. You know,
There's still hope. I think there's hope.
I actually saw the female got off the nest before the male came back, the male's shadow, and
Mm-hmm.
she actually left. And the nest with snow around it was actually exposed for about 20 minutes. And then she came back.
Really?
And that's like, yeah, that can't bode well for little eggies and potentially little tiny, chicken embryos.
Yeah.
I'll have some fried chicken embryos.
Mm.
Dan Aykroyd as one of the Coneheads. Saturday Night Live.
Oh, Carl Becker asks, maybe AI could be used to eliminate the satellite trails. Is that possible?
Yes, actually, if I scroll down here on the right, okay, look at this sentence right here. Remove satellite trails is off right now.
Okay.
So I can turn it on, and it can remove satellite trails. Now, why isn't it on then, you might ask? Well, it's not on because I have not actually tested it actively.
Okay.
Because I don't want to have the data compromised by,
Understood.
see what I mean? I'd rather remove the satellite trails myself later than let this try to do it. As it is, I'm letting this, I'm not letting this do anything to the raw data. The raw data is coming through just raw. But the pictures I save as just these saved photos that you get to see and download, well, those are processed a little bit. I get rid of some noise and stuff, So that you get. But the raw data are those FITS files, the FITS. That's an astronomical file format that we use as astronomers. And we'll take those FITS files and process them. And the processing we do on these FITS files will allow us to actually get the data to pull itself out from the background, and that's very important to do.
Okay.
Yeah.
Have a good night, Ronald. Sleep well, brother.
Ronald, you leaving us, brother? You can't leave us.
Right?
Ronald.
He said he took his sleeping pill pretty early, so he's gonna pass out.
Oh, okay. All right, Ronald. Hey, man, have a good night. Thank you so much for coming. Everybody give Ronald a round of applause. He's one of our primary supporters of SkyTour live stream. Thank you very much. I can almost hear him laughing now.
And he's an all-around good guy. He's a wonderful.
Yeah,
person.
you've never met him. I have. I've met him several times.
We've only spoke on the phone,
Yeah.
for a while, but it was what we've, those conversations that I've had with him. He's a down to earth, very very kind.
Yeah, he is.
Absolutely.
And he's a veteran, and he was on a ship that we talked about, him and I. As you know, I do work for the Navy, so I build models of ships for the Navy and for defense contractors. You gotta do something, right?
Mm-hmm.
Yeah. And that led me down the path in the past of having a fairly, good access to special projects and stuff. And I spent a lot of time working on those projects. But it was very invasive with your home life because they could show up any time of the day or night to do a spot inspection or check for bugs. And they did. I think the latest I got phone call comes in at 3 a.m, and I got to talk about a pending trip to New York City that I had to take for them. And it was 3 a.m, and I just wasn't prepared for a 3 a.m. call, So I was like, what? Oh, yeah.
Right.
Yeah. No, I'm here. I'm here. What? Who's this again? Oh, Marty. Okay, Marty. Yeah, I know Marty. Marty. Oh, yeah. Right. NCIS. Right. That Marty. And we're all actually. It turns out that, whenever you do programs like that, you take entrance and exit polygraphs a lot of the time. So I've probably taken more polygraphs than anyone should ever have to take.
Wow.
In fact, I got so good at it that I learned how to beat them. And I told the final examiner that came up on one of the programs I was on, they had to bring one in from Washington, D.C. to Groton, Connecticut, because everybody that does them in Groton, well, they became my friends. And then they have to recuse. They can't do it once they know you and they, this guy's cool, or they like what I do.
Yeah.
So they had to bring one up from Washington, and I opened up the conversation. I was like, hi, sir, how are you? I'm Mark D'Antonio. I'm going to lie on your polygraph, and you're not going to be able to detect it. Yeah, I straight up told him, and he looked at me and goes, probably not a good idea. We'll probably detect it. I go, I don't think so. And so...
So you got two questions
Okay.
here, Mark. One from Stan. What are your settings to get your histogram so far to the right? Is that right from the camera, or is it in SharpCap?
It's a combination. Was this from Stan, you said?
Yes.
Okay, all right. I did.
Two Rivers of
Yeah,
River
sorry,
Shore.
Stan. I didn't see that question. Oh, there it is. I see it now. Yeah, no, it's partially within SharpCap, but here's what I did. Look at over here. I actually zoom in. I zoom the histogram a lot so that I can get more control. All right. So that's what happens here. So this is also camera response. Okay. So if I was to bring this here, you know exactly what would happen. This is called a push process. And you end up getting a really bright screen, but you see more detail. Right? But you also increase the noise. So I tend to pull this way down, this mid-level. There's actually another level here, and it's way off at this end. Okay? And that is the white level. See that? The white level's way out here. So I actually do this here. So it's sort of a magnified view of it. So it does zoom in on it a little bit. Yeah. Let me know if that's enough. If you need more information, I'll be happy to give it to you, Stan. Steve Tuttle says, shortly after she laid the egg, she stood over them for more than several hours below freezing temps, high winds. That's why they're not hatching. I think so. It's like, but see, they had successful broods before, so they know what's going on. It's not like they're amateurs at it, first-time parents, if you will.
Check for a moment. Messenger? My messenger or Michael Hendricks' messenger?
I don't know.
The Jen goes, Michael Hedrick says, Mark, if I ever ask you to do a classic old naval ship my grandfather was on, would you make a model? Do you or do you do?
Yeah, we actually do custom jobs all the time. You know,
Right on.
we're doing a job right now for a DoD contractor, 21 submarine models. Yeah,
wow.
and they're all for part of the Columbia submarine program. Some of them are just about 2 feet long, and then some of them are 3 feet long. And the record for that size, for that type of program submarine is 11 feet, 12 feet.
Wow.
Yeah, all fiberglass. It can be a canoe. You could ride this in the river, you know, paddle. Yeah. So,
Ian, have a good night, brother.
Ian Kendall, thanks, man.
Thanks for joining.
5:45 bedtime. Jeez. Yeah,
Right?
he doesn't work during the day.
Right.
Great to see you from Liverpool. Thanks for showing up
Mhm.
and spending time with us, as always, Ian. We'll talk in Facebook, of course. And Dean Bostador. I know you're late. What are you going to do? Come on now. All right.
Oh,
These
go
these
for it.
two folks down here. This
Oh,
is
okay.
Michael and this is Tiffany. Now, who are they? Michael is one of the
Okay.
people that donates all of the telescope equipment to us, and Tiffany is the one that tells them to.
Yeah, pretty much.
So together, the pair of them have picked SkyTour Livestream as their exclusive distributors for free equipment that we give away on some of the streams. and that's coming up earlier in the stream that Michael showed us some of the stuff that he has currently. And when we're ready to do another giveaway, we will do it. Yep. And we're thinking of some clever.
Should I run with it?
We're thinking of some clever ways to have a contest too.
I haven't done this in a while. It's been like last hour. Okay, we'll do it.
All right.
Here it comes with the box.
All right, let me expand the box. There it is. Okay, this is a Celestron Star Sense Explorer. It's a full-blown telescope. You use it with your cell phone so that you can actually, literally, it's not a go-to telescope, which will go automatically. You move it. However, your cell phone guides you to it.
And it's super smooth, like unbelievably smooth.
Yeah, so that's really cool.
The actions are really smooth for this telescope.
Yeah.
And also, oh my goodness.
God.
And one more item up for bids, and the price is right. Okay.
All right.
Oh my God, almost fell.
Sorry.
And then we have the Celestron 7x50 Cometron binoculars, which Michael and Tiffany are giving away on SkyTour live stream sessions. And I'll bring the size back down now so you can watch the galaxy coming in. The nice thing is, okay, if you...
Among other
Yeah,
stuff.
yeah, we also have night vision system by Psionics that we're going to be giving away.
Once we reach 20,000 subscribers, I already
Yep.
said that. 20,000 subscribers by October 31st, we'll be giving one away.
Wow, that's ambitious. Otherwise,
Yeah.
all of you in the chat have to buy us Psionics. No,
Exactly. A 14-inch
Yeah, right.
Dobsonian.
Oh, not a Dobsonian. Heck no. Yeah. Buy me a 14-inch cardboard tube. That stands like 9 feet high or 7 feet high. Totally unusable. Totally non-roboticizable. Yeah.
Right?
But there's something to be said for manual operation. I understand that. I
Yeah.
used to do it.
Oh,
As a
yeah.
kid, I used to do it. Star hop. My first
Right?
telescope mount was made out of plumbing pipes. And I made a full-blown equatorial mount that could align with the North Star, rotate with the Earth's rotation. And I was able to just effortlessly keep stars in by just tweaking it just a little bit and moving it slightly, and bam, there it goes. The telescope would move a little bit. It would follow the stars nicely as long as it was aligned with the North Star properly. Now, you can imagine
That's awesome.
how much more complicated this system is that we're using. Okay, this telescope above me here in the observatory, this telescope is 400 and something pounds, and it's sitting on a big steel pier I had made out there, and it's bolted into concrete. It's bolted into 10-inch concrete floor. It does not move. It just, the wind catches it, and the subtle vibrations can make it move. But that's about it, and that's only on windy nights. Brandon Hill is with us. Hey, Brandon. Hi, Prow. Prow is with us. I see that. Brandon Hill says, I still have my 8-inch Orion Dobsonian that my dad got me some 30 years ago.
That's right.
Wow, that's pretty cool. And he learned to star hop.
That's
Star hopping is what we used to do, you know? Yeah.
Hmm.
Brandon, thank you. And guess what, Brandon? You know what I have out in my shed right now? I have an 8-inch Orion Dobsonian. Okay? Same one you have. I have out in the shed right now. And I've never used it. It was brand new when I got it from a doctor that was moving out of state and just wanted to get rid of it. So I got it for $100.
What?
Never used it.
Yeah.
You got it for $100 and never used it.
Garbage
So how
is
much would it?
that?
How much would it be to ship to California? Wait, are we not meeting in Arizona next week?
Yeah, I mean, if I could motorize it, I would have already. Yeah. They have Dobsonian motorizing.
I'll bring you $100.
Yeah, well, $250, it's yours. No.
Hey, 250
right.
in euros.
Yeah,
I'll bring you
yeah,
euros.
well, don't say that. That's more than $250 American.
Right,
I'll take that.
right on.
So that's very cool. Yeah. So this is the galaxy that looks like a steering wheel, as you can see.
Yeah.
And that I'm going to show you that because we're going to zoom in on this now. We've got 39 done here.
Nice.
See the wheel?
Yeah.
Okay, this
That is
this is the
Yeah.
bar. This is why it has an S and a B, capital S, capital B. It's a spiral, barred. It means there's a bar of additional stars through the nucleus. It's not just a round nucleus like in our galaxy. Well, actually, our galaxy is one of these. It's a barred spiral, but like in the Andromeda galaxy. And the spiral arms come off the end of the bars. See that? Those spiral arms are starting there. They're not coming out of the center. See, that's a void there. And so you can see that this thing looks like it's rotating this way, doesn't it? Because of the way the arms are sweeping back.
Yeah.
Yeah. Django says messenger for Sir Michael T.
Oh, okay. Let me go. All right. He wants me to check it. Check it real quick. Oh, let me back out. Oops. I have to back out of this real quick. Actually, I'll minimize it. Oh my goodness, Shadow. Come on now. I'm going to have to mute. Hold on.
Because he's yelling at the cat. Okay. Now let's go back to our... let's go bring that back in. M95. Michael Hedrick says binoculars in Death Valley. Awesome. Yeah, I believe that. I certainly believe that. Binoculars at SkyTour Livestream West. Haha. Extremely awesome. Giant telescope at SkyTour West. Even more extremely awesome. Very cool. Alright, so this is Measure 95. I'm going to put that in here. M95. Named for Charles Messier's catalog, the Messier catalog. Alright. Okay. Saved, and we'll save it exactly as seen. I know Brandon. Brandon says, same one, small world. Yeah. It's really kind of cool, you know. I got a lot of accessories with it and everything. And I was just pretty certain that we were going to get, I was going to get to use it. But then I realized I'm going down a path of automating the observatory, and a Dobsonian wasn't the best choice for that. But I've seen some big Dobsonians. How about a 25-inch Dobsonian? I think the record one that I ever saw and used was a 40-inch. And that one was at a star party somewhere. You had to climb a tall ladder to get up to the eyepiece. All I could think was, I want a camera on this thing so I can just look at a TV screen and not risk my life in the middle of the night. Can you imagine the police? I'm sorry, but he fell off a ladder looking through an eyepiece. He fell inside the tube, and it took us 2 hours to pull him out of the tube. And we called the bomb squad because we thought at first it was a cannon. Okay. Let's save this. We'll let this one more come in. Meanwhile, while one more is coming in, let's go find one more thing to look at here. Okay. You see by the angle, that's the equatorial coordinates. Alright, let's see here. Yeah, it's probably a good idea for me to shut down here because we do have to set the clocks ahead. I'm going to lose an hour. Okay.
Yeah,
Hell no.
yeah, I totally forgot about that.
Yeah, you'll need that.
Yeah, that's horrible for me, actually.
Yeah. Okay, here's what I'm going to do.
And Django, sorry about that. Found it. Oh my god. That's what he sent me.
Wow.
Oh my god.
Yeah, you going to share it with the whole class or what?
Yeah, of course I will. Oh my goodness. This thing is... Oh my goodness. What a setup. Hold on. This is a video, so let me get this set up here. All right, starting now.
Okay, let me...
Oh, let me rewind it. Okay. Look at this thing. That's his setup.
Oh,
right?
very cool. Yeah.
Right. That is a very fluid motor right there.
Mr. Django, it looks like a Paramount. Is that a Paramount? Or is that a harmonic? Let me know, Mr. Django.
That is awesome. And this is what he captured with this thing.
A raccoon? No. Yeah, that's the whirlpool right there. Yeah.
There's the whirlpool. It is amazing.
Ronald.
Thank you.
Ronald
so
says,
much.
"Can I get a blanket with the Andromeda Galaxy?" Yeah, actually, Ronald, I'll make one up for you.
And why are you not on my friends list, Steven? I'm adding you now. Good lord.
Yeah.
No, he had sent me a message and I couldn't find it, and I found it in my spam for some reason.
Yeah.
Under message requests. It's like not even. It's not cool at all. I don't understand why it went there.
Okay.
Thank you so much for sharing that, Steven.
That's very cool,
Amazing.
Steven. All right, so that's good there.
Right on. He said it's an AM5 harmonic.
Okay, so it is a harmonic. It looked like a harmonic to me. I was investigating the harmonics because the counterweights are not totally necessary, but there's weight limitations for the harmonics and for what I wanted to add to it. Like for instance, I have a spectroscope here, a spectrometer that I want to add, but I'm probably not gonna add it right away, but I can add it to the second Arizona scope. That way we can actually take a spectrum, for instance, of the Orion Nebula or of stars, and we can see the actual spectrum. And I have a professional grade software that literally allows you to identify every single element and compound that you might see in the spectrum. So that's something that I'm looking forward to doing. Ronald has a comment for you, Tiffany.
You see it?
Oh. Thank you.
He thinks you're a cupcake. You're a great hostess cupcake.
Delicious.
A chocolate cupcake with a little squiggle on top of white. The little white squiggle on top. The chocolate.
Yeah.
Yeah, I used to eat just that and throw the cake away.
Right.
Then I realized, wait, there's something inside of it. Ooh, filling. Okay,
Right.
let me,
Oh, that's awesome. If any of you who are watching are from the groups on Facebook, Astronomy, We Are Not Alone, NASA, National Aeronautics and Space Administration, thank you for joining us. I just wanted to give a shout out to you guys. I also want to thank the admin for allowing those posts onto their groups. Thank you so much.
and if someone is watching from came here from one of those groups, let us know. We'd like to know where you came from.
And I would definitely like to personally thank the admin, which I always do. I always leave a comment when they approve the share.
Yeah, you're good about that, which is kind of nice. Okay, let's see what else we can do here. I'll just do one more thing. I'm going to do this beautiful beehive cluster. We'll make this the last object for tonight.
Yes. Beehive cluster is beautiful.
It is. You'll actually see it come in here momentarily. Okay, you watch the stars zipping through here, and you'll see all of a sudden lots of stars in the view. Okay, there they are. That's the beehive. Why is it called the beehive? I can't tell you. It's also known as Praesepe.
Persepi.
Yes, Praesepe.
Wow.
Okay, so what we'll do is we'll bring this down a little bit. We have a nice new moon out there, so we don't have the moon to contend with right
Right.
now. Oh, look at that. Let's head west.
And west.
Yeah, just pull us over a little bit westward. Ah, this is a perfect song for the beehive. And we'll start a quick exposure of maybe 20 seconds. Don't need that many for this. And we're going to be seeing beautiful new stars. A few tens of millions of years old.
Oh,
Yeah, that one there's there. Okay. Ronald, you will order a Andromeda blanket by selecting it on the radio, selecting it on the SkyTour live stream store. It's not there yet. I'll put it up there. I'm doing it as a special order for you, Ronald. And if you don't feel obligated to buy it, other people will buy it if they want to. All right, let's do this. And look at that. So now let's show this the way it ought to be shown. Okay, color correct it. Okay. Now let's just take this out of the way for a minute. And there is your cluster. Here is the beehive. Look at all the complexity in there. Look at the stars. Wow. That's really pretty. Now I'm going to just do one thing here. Make sure. Yeah, we're up to maximum color. That's good.
so I have a question. Are there any? Do we know of any planetoids that might be?
No.
I mean, have any of these stars been investigated for like star wobble or any?
Well, star wobble. Okay, first of all, let's talk about that for a second, and what does that mean to the folks listening?
Okay.
Okay, this cluster is let me just zoom in here for you. It's about 570 light years away, 580 light years away. So it's pretty big in our sky, right? And you can see how big it is in our field of view here. Okay.
Mm-hmm.
Star wobble is when you see a star moving because planets are tugging on it. That's called astrometry, and it's actually one of the astrometry, metry, astrometry, and it's actually the most error-prone methodology. Yeah, really? It is. However, to be fair, there have been some exoplanets found that way, but the best way is to look for transits. And if you think about it, solar systems, star systems can be at any angle to us, you know?
Mm-hmm.
So we do a number of ways. We have a number of ways to detect whether a star has planets around it. For instance, let's come back here. Let's suppose we're going to focus on that red star right there. Okay?
Okay.
You say, okay, let's look at that red star. Well, that red star is under examination, say. We're watching it carefully. And we're going to look to see if the spectral lines in that star's spectrum That is to say, the signatures of the chemical composition of the star, which we see in the spectrum, shift one way or another. Okay? And that shift would be due to something called radial velocity. The component of the speed of it moving toward us would make it bluer, and the component of the speed of it moving away from us would make it redder. Why would it move away from us? Well, if a planet was going around it or tugging on it, the star, they would be orbiting a common center, and that common center means that the star is going to kind of make this motion in space. And as it comes toward us, we can calculate how much it is, and as it goes away from us, we can calculate how much of it's going away from us. And we figure out the radial velocity, the velocity component along our line of sight. And that can tell us things about what type of thing is orbiting it. Is it being orbited by a black hole? Is it being orbited by a faint star? Is it being orbited by a bunch of planets? Or just one giant planet? We've seen all those things. So, not in this cluster, but so in other words, that radial velocity is one way we can detect things. Another way is the transits. If it just so happens that a planet's passing in front of the star as seen from here, then we might actually be able to see a slight dimming of the star's light. And we do. Okay, Kepler saw it, TESS saw it, ground-based astronomy systems saw it. Okay, so that's another way. Yet another way to find out if there's a planet around a distant star is to look and see if the star's image is being gravitationally lensed. That is to say, the gravitational tugging can distort starlight. And so we might see that distortion in a periodic manner. And then we say, oh, that's a gravitational lens. We found a planet. And so there have actually been several things that have been, several planets found that way. So we have astrometry, we have radial velocity, we have transits, we have gravitational lensing. It's called microlensing. Okay, and so those are kind of like the primary ways in which we discover planets around other stars. There's one last one that is kind of interesting, and that is direct imaging. Wait, Mark, you mean seeing planets directly? Yes. In some cases, we can actually see planets directly. Okay? And it could be in the infrared, okay? But it's also a way to actually, or it's actually something you can do in direct visible light. It's just that it's not that easy. It's usually going to be done with infrared. The Gemini telescope system up at the Keck Observatory in Hawaii, up there, that discovered a star system that had planets in it. And if they block out the starlight, because stars are only ever points of light. So this star we're looking at right there, that red one, that's a point of light. It's less than a pixel in size in reality. Okay? But if we look at it up close, okay, you'll see that this star is bloating many, many pixels. It's filling so many pixels here. See all of those? Right. It's actually bloating and it's filling so many pixels. But the actual star's brightness is less than a fraction of 1 pixel in size. So look how much bloat the brightness is. Yeah. And that's what happens. We see the bloat. So what do we have to do? We have to remove the brightness of the stars from our images, because the entire star system, all right, let me move it again, at say 500 light years away, the entire star system might only be in the size this big. The entire star system out to the edge of its Kuiper belt, well beyond what might be Pluto here, okay, would probably be maybe this size, okay? So what that tells you is that we have to block this light, and that's done with an occulting disc that is used electronically in the telescope to actually block that, and then you actually can see what's around it closer to the star. And it's best to do these observations from space if you can, but traditionally they've been done from the ground. Okay, so let's see. We got a number of beautiful images here of this beautiful beehive cluster. So let's dock this up here.
Django, I learn something new every time.
And I will save this. Let me first of all name it the Beehive. Yeah, gotta do that. Not Custer, cluster. This is the Beehive custard. What? Okay. Now we'll save it. Wow. Folks, hey, thank you so much for joining us tonight. We had a great time. Michael and Tiffany, thank you so much for coming out. You're free to join us anytime, so it's really cool to have you on board.
Thank you very much for having us.
And hopefully, I'm hopeful that when I go out there next week, we might be able to do a stream from out there, which would include seeing the new all-sky cam in operation. So, because all I have to do is screw it to the building, I'm going to screw it to the top of the post on the end, have it on a pipe, long post, and I've got more than enough cable, and I have the systems out there to do it, and we will make this all work. Looking really forward to it. So thanks, guys, for joining us tonight, and we're going to call it quits for tonight because it's a long night. I'm starting to slur my words a little bit.
Yeah. And I'm crashing
and
fast.
You have to.
I'm like, I've been inundated with so much knowledge, and I'm just like, I just forgot everything I learned last week at work. It's like out with the old and with the new. But no, this is, I learned something new.
Ronald, I have to answer Ronald's question before we go. He says, will you have another all-sky cam for the new location? Ronald, of course. Yes, I tracked the cost of this one. This all-sky cam cost me about $700 total to build it. If I bought it, however, a all-sky cam with this capability, it wouldn't be as capable as what I've got, and it would have cost about $3,000. So $2,500, but I made this one for $700. It's completely waterproof. It has heat to get to the dome to keep the stuff off. Any snow or ice or water will quickly evaporate. So it's actually quite nice. The only thing I can't keep off of it are birds. They like to sit on the domes of these things because they're the highest point, and then they poop on it. So I'm working on it right now, but it's a little device that's a little scarecrow that as it sees a bird approaching, there's a sensor that detects any incursion into the space. It flips up this big thing that, like a paddle, goes and scares the birds, and it won't land. And then it just goes right back down. So over time, they will be habituated to not landing on it. But unfortunately, that won't be until the next time I go out, which will be in May. Because actually, a Navajo friend is having a birthday party, and I'm going to be going out there for his birthday party. And then we have Contact in the Desert.
Contact in the Desert, I can't
where
wait.
These two characters are going to be.
That's gonna be
Yeah, you guys have to come to Contact. And by the way, anyone who attends any of my talks at Contact, I'm doing I'm doing a workshop, which is going to be a SkyTour live stream, one of these. Okay. And that'll be a night project. And then I'll be doing a lecture during the day. And I think that's the intensive. I never get those straight with them. And then I'll be on Ben Hance's Skywatch, because every time Ben and I get together at a conference, we want to go work together. So I'll be the astronomer for his Skywatch. But anyone who comes into my talks, my workshop, or the intensive, when you walk in the door, you get a ticket. All right, and that ticket can win you one of those prizes that you saw Michael hold up before, either a full telescope or a pair of binoculars. Okay, let me just bring it up. So if you guys are gonna come, you can win these binoculars. Okay, you can also, it's like, thank you, Vanna. Turn me a little. Oh, Vanna, turn me a letter. Yeah, and of course, I won't reduce it until Michael shows it, but he's going to bring it over one more time. Okay.
Oh my God, this thing's...
He's bringing the telescope.
The other prize you can win is a full Celestron Star Sense telescope from Celestron, makers of the finest equipment. So these are meant to get you started in astronomy. And if you can get started in astronomy, you'll end up looking like Mike. And that could be problematic if you know, well, maybe. Not if you have someone like Tiffany around. If you have someone like Tiffany, you're right in. You're good. That's good. So, guys, thank you so much for joining me tonight. It was a lot of fun. You guys are, of course, outstanding co-hosts. And
Thank you.
funny. You got a lot of comedy in there that comes off really well. You know, so looking forward to doing this again with you guys. And I will save our latest beehive out to our satellite, which will take it off to our server, which you will get access to within 30 seconds. All you gotta do is go here, skytourlive.org, find us, love us, give us a thumbs up, join us, subscribe to us. If you're not a member, please subscribe. That's free. Okay. And Ronald, who ERRT Radio in the chat, has a pair of binoculars that he won from you and Tiffany. Okay. So he's very happy with those. And I am very happy that he won them. It's fitting that people who support us for a long time get to win some things from us. Very nice.
Exactly.
And Fantasy
And
says which days. I don't know, but I think that it should be published online. Do you guys know if the speakers schedule?
It hasn't been published online yet. Yeah, we're still waiting to hear from Ron. So,
okay.
in that regard.
Ron Jenks is the guy behind Contact in the Desert. He's a fantastic guy, good friend. I've known him for many years. I was very surprised when he invited me back a second year in a row. And this year we're going to do even better. My first SkyTour live stream I did last year out there, we had 205 or 210 people outside in flimsy little chairs watching our inflatable screen. And that was Ben Hansen's inflatable screen that we borrowed. And it's going to be even better because this year it's going to be indoors, more controlled. There won't be any flimsy chairs. It'll be comfortable seating. It'll be like going to the movies, except it'll be interactive. You know.
And you might win something if you
That's
get
right. Each event, you'll get a ticket. As you walk in the door, you get a ticket to win. So just by being there, you can win binoculars or a whole telescope system. And no, we're not going to make you carry a giant telescope box out of there. We'll send it to you. Don't worry about that. Now, the binoculars, on the other hand, you can walk out with those. Because then when you go into one of the talks, you can use them to see the guy up on the stage.
Right?
Yeah.
That's my favorite speaker.
That's right. All right. Well, guys, thank you again for joining us tonight. All of you that have watched, that love it. Thank you so much for joining us. And we will see you again on another SkyTour live stream. And if you haven't, you can find me at skytourlive.org to ask me questions. But if you want to see me doing other things, you can watch History Channel. You can watch The Proof Is Out There. You can hear me on Friday nights on Night Dreams Radio, a nationally syndicated show. I do an astronomy segment. Last night, Friday, is today Saturday? I lose track of days. Okay.
Yeah.
Last night, I did an hour and a half on the show with the host Gary Anderson, talking about the latest astronomy and also UFO sightings, because I'm also the Mutual UFO Network's chief photo and video analyst. So I don't have a life. This is my life. Well, thank you guys. Anyway, check us out. Don't forget, the Etsy shop is SkyTour Shop up on Etsy. And if you want to find cool things, you saw what Michael and Tiffany were showing you before. Well, join us there too, and ask questions if you want, because you can always reach me at skytourlive.org. All right? You can find me there all the time. All right. Thanks, guys. You guys have a good night, and we'll talk to you again.
Have a good night.
See you all later. Good night.